All right, so we're back. Um, I think you can hear me, right? Okay, thank you. So yes, now we're back, and we're coming back for the part 5 of this Pyjamas Conf, and hope you're enjoying this. So we are right now we have some amazing talks and excellent speakers. So next, we will have a recorded talk. We have Aline Ferreira. She is computer engineer at IFCE. She works as a back-end using Flask, co-organizer of PyLadies Fortaleza, Book CE, Python Nordeste, and Python Brazil. She also do as a tutor of Bash and Shell kittens. So she will talk about Kiwi and how to stop being ghosted in dating chats. So let's join her, and she will teach us how to create a platform and reverse the situation with Python and Kiwi. So we can start it right now.
If you want to speak as a Brazilian. And hello, I'm Aline, I'm from Brazil, and this is Pyfinger or Pytinde if you want to speak as a Brazilian. And I don't like too much this age, but because of copyrights, I prefer to put it. But in Portuguese, the pronunciation is Pytinde. And it's a way to use kid to not be ghosted. So let's go. But first, this is my team. Aline is the front end, Ferreira is the back end, and Souza is the QA. So if there any problem or any bug if with the application, it's not my fault. It's fault of one of them. Okay. Certainly, I'm a computer engineer. I'm a Flask developer, and I'm organizer of PyLadies Fortaleza. It's a local chapter. PUGC, it's Python Users Group of Ceará, and Python Nordeste, like Northeast, and Python Brazil. I'm Shell and Bash owner. They are these two little cats, and I'm a dancer. I think you know it because of my last slide. And the motivation. My motivation is because I wanted to see more talks about Python for mobile devices. And I reviewed a lot of talks in Python Brazil 2020, 21, and 22. And I think there was just maybe four talks about mobile devices, and all of them using JavaScript, and none of them using Python. and it's a Python event, so I think it's nice to have talk using Python for mobile. I think JS is cool too, but it's Python, but it's better. Uh, and I wanted to have a pet project. I work with Flask. I know Django, so sometimes it's boring to study what I'm using all day. So I started to study Kiwi and KiwiMD just to have a pet project. And it's a joke in Brazilian community. Every year in Python Dash, Python Brazil, and I think in other regional events too, people ask about Pythinder, and yeah, no one did. But every year people say that they will do, but they never do. And it's the next point. Nobody did, so I tried to. And I really want to find collaborators because if it depends just on me, it will not be finished because I don't have many time. And yeah, if anyone want to help us, help me, I will be really glad. And the libraries. The main libraries are Kiwi and KiwiMG to draw the screen. Python and Bulldozer. Python to compile Python to C, not to C, but to C. And Bulldozer, it's used to build the application and put on the smartphone. But there's a problem. Pillow is not added by default, so the application works on the computer but doesn't load correctly on the phone. It's used by KiwiMD and I think by Kiwi too, and it's not added by default. So when we use the application on the phone, they appears, load, and then disappears. So the solution was add pillow to the poetry and build other files, and that's all. In theory, if anyone use my repository with the specifications, it will work in theory. So in the main libraries, I added pillow, and that's it. The files. The files used to build Zap were poetry.log, its package and their dependencies. PyProject.toml, there are the libraries in use. Pythinder.qv, that's where the widgets are. It's the project definition. So the blocks of code, the components are defined in this file. Pythinder.py, it's the Python file where the basic settings are. So you see that. The main py is the Python file where Pythinder is called because it's needed because the bulldozer need main.py. I can use the code of Pythinder in main.py, but I don't like it, so it's separate. And the bulldozer spec, it's the specifications that the bulldozer we use to build the application. Hot hello, what is that? It's a file. It's a way to change my files, change my code, change my application, and don't need to finish the file of Python and start again. So it refreshes magically, and it's really easier to programming using a hot hello. That's the class of hot hello. The debug is set to true, and the build app will return the builder.load file and the path to the file that is my widgets. I can define the widgets as a string, and the load file will change to load string. But I don't know, for me it's prettier to use the file. And we call the hot hello.run to run my application. And here we will talk about the files to really build the app because the hot hello is just to help us. The pytinder.py, that's the class, and it's quite similar to the hot hello, but it's not be called here because we will call the pytinder on main.py. So here we can set some attributes of my class. And the theme style here is light. It can be changed to dark. Uh, it can be changed, not just uh, changing the file, but we can, I don't know, put an action to when I click a button, it changes to from light to dark, and that's. And we have the primary palette. In this case, it's blue, but we can change to a lot of colors. And it will return a builder load file and the path of the file with the widgets, like it was on the hot load. The widgets. There are many widgets, but we will use basically 6 of them. That's the MD screen. It's the main component. It's literally the screen. We have the MD sweeper. It's a block that groups the items to be swept. And the MD sweeper item. It's the item to be swept. So the MD sweeper is like a container, and inside of it we have one or n, a lot of super items, and we can set, in this case, images. So we need the fit image too. It's a component with image attributes. And we have MG box layout. It's a component used to group buttons. And MG icon button. It's a component used to define buttons and icons. So it's similar to the sweeper. We have the MG box layout, and inside of it, we have the MG icon buttons. So this is the app, not just this, but in pytinder.kv, if we put just the MD screen, the hot hello will load just a blank page. I can change the background color, but I just want to show the MD screen and just that. MD sweeper item, and fit image were used to do this, not this GIF, but the application. And in the MD sweeper, we can set the ID, we can set the size hint Y, we can set the height and the Y. And for each one of my MD sweeper items, we can use the fit image because in this case, we are just loading images. So we have size hint Y 100%. So we use all of the height of this sweeper. We have the size hint X 75%. So if the two numbers are equal, like 1 in 1, we will have a square. And in this case, it doesn't make sense because I want something similar a photo. And in general, it is in portrait mode. So it's a rectangle. And to load the image, it's just this line that will be different between the files because it has the name of the file. So the source is the path to the files. And we have the radius, in this case 20. We didn't see in this image because the background is white. But believe me, the corner of the image are rounded and the radius is used to round it. And we have MD box layout and MD icon button. In MD box layout, we have the adaptive height. So if I change the size of the button and it was higher than the box layout, it will be adaptive. The orientation is horizontal because I want the the buttons should be one on side of other and not one above other. So we can put horizontal to because of it. We have padding. Padding is where this will start. So we have the hood width. It's the size of my width, the window width. If I change the size, it will change too. It's divided by 2 because I want to start in the middle. Minus 130, it's the size of the buttons and the spacing. Basically, I try to change some numbers, but in general is it. And the spacing is the space between the two buttons. And the MD icon button is similar to MD of JavaScript. So the icon is the name of the icon. I have the close, it's the X, and I have the heart, that is the heart. The theme test color is custom because I custom the color. And if I don't have this line, it will be ignored. So it's really important to have this line. I spend a lot of time trying to understand this. And the MDBG color is the background color. This color is the hexadecimal of the yellow from the Python logo. And the icon color is the hexadecimal of the blue of the Python logo. Yeah. So it's basically the application. We don't have action in the buttons for now. We just have the sweeper. But I really like to implement that. So it's the app time. We have to build this because for now it's just on my computer using the hot load, and I really want to test it on my cell phone. So my hint is never use the command bulldozer disk clean or use it, but knowing that it will probably break your environment. I don't know if it's a real truth, but I broke my system, my environment twice using this command. It was the last command before I tried to use and my application doesn't work. So I think it's because of that. And this is the security commands. We have the bulldozer init. It is used to initialize the bulldozer spec. We can change the specification after, but we have to initialize using this command. We have the bulldozer -v for verbose. Android is the name of my operational system. It can be iOS too. And debug, that is what I'm doing, debugging. We have deploy, run log catch, and the clean. It's safer than the dist clean. But the command I really used was bulldozer android debug deploy run log catch because it does everything. I will compile my Android file, I will debug, I will deploy to my cell phone, I will run, and I will catch the logs. So it's time to change my screen. So just to show you, in the app we have putting the KV and Python. We have bulldozer spec. In the bin we have the APK. I have the hot load, the image, the main, the poetry, the project, and the hidden readme. And we run the command and wait a lot of time, and I will change the speed of it. So the application is loading, and here's my app. I can sweep the image, and in theory, I can click on the buttons, but it doesn't have action yet. So I will change my screen again. It was the screen of the application. For the next steps, I want to put images in the cloud because for now it's on the folder, on the application folder. So it's loaded on my cell phone. It's not really nice because it will be inflating my app. And I want to use sweeper to change people. I tried to use a sweeper inside a sweeper, but when I slide, it's like the both of sweepers, so it doesn't work. But I don't really think it's needed because we can use the sweeper to sweep the emails and choose or not choose the person using the buttons. I really want to do the chat because for me it doesn't make sense connect people if people can't communicate. So in this point, at this point, we can talk about the synchronous communication too. So it's a really cool topic. And I want to publish on the app and Play Store because I want people to use it. I know it's a joke, but I really want people to use it because I really it's a nice project. And yeah, the references. The first one is the link to my repository on GitHub. The second is the read the docs of KMD, and it's not like just read the docs, but when I was searching things, it was like MD sweeper item KMD, and the Google returns me the read the docs. So it's a really nice material. And the last one is for people who understand Portuguese because it's a video. And it's like Android application with QMG. It's from LabG Python. And please make a pull request. You can make suggestions, open issues, make pull requests. It can be in English or in Portuguese, or maybe in Spanish, or the language with Google Translator. I don't know. Just be happy and make a pull request. And thanks. If you have any question, this is my email and social media. It's Aline FS or underscore Aline FS in the social media. And the email I will spell because my name is strange in Portuguese too. It's ALYNNEFERREIRAS@gmail.com. So that's all. Thank you for watching and make pull requests. Bye bye.
Sorry. Yes. Now there it is. So we're coming back for more, and we'll follow up with another recorded talk with Rob Richardson, who will be talking about async Python, uh, good it is, where we'll see how easy it is to do multiple tasks in one, and how we collect all the results. We'll also look at the best practices and edge cases, like how to start an asynchronous process from main. Uh, well, um, Rob is a software craftsman building web properties in ASP.NET and Node, React, and Vue. He's a Microsoft MVP, published author, frequent speaker at conferences, user groups, and community events, and a diligent teacher and student of high quality software development. He's a MVP, and well, you can find his desk and other talks at his blog. So we'll continue along with him.
Hi, welcome to Pyjamas. Today we're going to take a look at async Python. We'll get to look at a lot of code and how async I/O works. Here's the part where I tell you I am definitely going to post the slides on my site tonight. I've been that person chasing the speaker, which is why you can go to robrich.org and the slides are online right now. Let's head there. We'll go to robrich.org, we'll click on presentations, and here's async Python good it is. The slides and the code up on GitHub are online right now. Achievement unlocked! While we're here on robrich.org, let's click on About Me and we'll see some of the things that I've done recently. I'm a Shoreline developer advocate helping people to maintain Kubernetes. Docker and Microsoft have each given me some awards, and I'm also a friend of Redgate. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp, or if you'd like a GiveCamp closer to you, find me here at the event, or hit me up on email or Twitter, and let's get a GiveCamp in your neighborhood too. Some of the other things that I've done, I've published a few books, and one of the things I'm particularly proud of is I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woohoo! So let's dig into async Python. Now, this is really fun. Let's first start with what is asynchrony. Now, asynchrony is being able to do more than one thing at the same time. Kind of. It's really about doing those things independently. We can do two processes that run independently and can reach their own termination points separately, which means we don't need to wait for each to finish before we start the next. Asynchrony, we can think of two independent things. By comparison, synchronous, is one thing after another. Why would we choose to do asynchronous behaviors? Well, it's different depending on whether we're on the client side or on the server side. For server side, we can leverage our hardware more effectively. So, for example, if we're in a synchronous world, we might divide our server equally, and you get one particular pie. By comparison, with asynchrony, we can yield our thread and let others use that piece of the hardware to be able to accomplish their task when we don't need it. On the client side, we're doing asynchrony to be able to do more than one thing at the same time. So imagine opening two documents at the same time. Now, if we had a synchronous process, maybe we could only open one document. We'd have to close that one to open the next one. So why wouldn't we do asynchrony? Well, synchrony is a lot simpler. Just doing a sync thing, we can read from top to bottom in our method. It's a lot clearer, a lot simpler to be able to execute. And one of the big things with synchronous behavior is we completely avoid race conditions. Well, what are race conditions? Race conditions is where we mutate shared state, and usually we can end up in some pretty awful concerns. So for example, let's imagine these two different developers or two different programs running simultaneously. Now the first one says, if the file exists, then load the file. Well, let's imagine that it checks to see if the file exists, and then the second program makes the file exist. So the first program doesn't believe the file exists and then shows you the message even though it does exist. Or let's flip this one opposite, and let's check to see if the file exists, and it does, and then the second one deletes the file. Then the first one goes to load the file and gets a file load error because the file doesn't exist. How is this possible? Because we're mutating shared state. We have a race condition. The way to avoid race conditions is either to run synchronously, not have the two pieces in the same spot, or not mutate shared state. So strategies for asynchronous things. There's lots of different ways that we can do that here in Python. We could do subprocess.popen and run another executable. We could do threading.thread. And so let's take a look at each one of these. First off, popen. Now with popen, we can just launch another process, which means we can start anything. Is that Python? Is that a shell command? Is that a Go app? It doesn't matter. We're just launching whatever we launch. On the downside, we have no visibility into that process. We can get standard out and standard error. Maybe we can stream that into place. But at the end of the day, really, we don't have any visibility into what that process did other than its exit code. And that exit code can be pretty opaque. 0 is success, non-zero is failure. But we don't have any way to pass variables between them. We don't have any way to understand how far along it is. This is a very opaque process. By comparison with threads, we get a whole lot more visibility. We can share variables between the threads. We can launch these threads and have them run in parallel. We can take a look at the things, and we can even pass messages between them, set variables, and read it on the other thread. On the downside, this process is ripe for, well, synchrony, race conditions. Debugging this is a nightmare, and the setup of threads is really awkward as well. It's very difficult to get this process to run effectively, and the code is, well, really verbose. So when we look at both of these mechanisms, we realize that asynchrony is really hard. And it is one of those things that we want to do to better leverage our hardware, but it's really hard to code. Now let's take a look at async IO. Async IO was built to be able to solve these kind of problems, to make it easy for us to program asynchronous code. Async IO is great at being able to think synchronously and run asynchronously. That's excellent. So in theory, we ought to be able to get the best of both worlds. We get an asynchronous program, but we get a program that reads more or less top to bottom. That's cool. Now, async IO, it was clearly inspired or stolen from C# and JavaScript. It has identical syntax to them, which is great in the same way that in C# and JavaScript, the compiler builds up this state machine. In async IO, the compiler will build up this state machine that is resumable. So once I finish this step, I can go off and do some other work, and I can come back and I'll start off with the next step. Now, all of this happens transparently just with the async and await keywords. Let's take a look at that code. Here's an async IO program. So we can see that we import the async IO library. We'll start some stuff. We'll call into some function, but we have the await keyword here. So it will go do that asynchronously, and whenever it finishes, we'll continue grabbing our results. Now this is an asynchronous function so that it can do that awaiting, and now we have that mechanism for being able to do asynchrony, but make it look synchronous. Excellent. So async IO, it's a lot easier to reason about than other methodologies. We can think synchronously, but it still works asynchronously. Now, async IO is not truly simultaneous. It isn't launching new threads, it isn't creating parallel processes, but it's great for IO-bound tasks where we're doing a lot of waiting for things. If we're waiting, let's yield this thread and let somebody else use it for a while. Once this process is done, then we'll pick up and continue on. If we really do want two compute-bound processes to run in parallel, then async is not the right solution. So async IO, it is great for IO-bound workloads because we're waiting for the result. But it's not great for compute-bound workloads because it's not actually running at the same time. Rather, it's just context switching between the two processes. So how do we install async IO? Well, we don't even need to pip install this. Starting in Python 3.4, it is built in. So we just need to import the library at the top of the code file, and we've got asynchrony. So here's an async program. And we saw this a little bit previously, but we can see how this program, we just add an await keyword saying we're going to go do some asynchronous work, and we'll have an async keyword documenting our function. So let's take a look at a code sample here. Now these code samples are up on GitHub, so you can come in here and you can run each of these samples. I'll open it up in VS Code. Let's start out with the hello world. We've got that synchronous method here, asyncIO.sleep. So it's going to just go off and do the sleeping thing, and we'll just run it. So Python 1, and we can see that it does that asynchronous work. And our program run length is 1 second. Now what's it doing in the meantime? Well, in this case, it's just sleeping. It's not doing anything. But we could just as easily wait for a database call, or wait for an API call, wait for another function to finish. That worked out well. We have this asynchronous function that is able to go off and do some other work. And once it finishes, we get the results in a really simple way. We don't have to grab exit codes and standard out and standard error. We don't need to do thread.join. We can just do our program as if it was a synchronous program, but it runs asynchronously instead. Now, one of the rules of asynchronous methods is that we can only await other async methods. And we can only have an await in async method. So it is kind of viral in that nature, where once we have an async method deep in our tree, then all the rest of the methods calling it also need to be asynchronous as well. Now, I did put an asterisk here because there are ways to overcome that, but for the most part, that's the methodology that we want to use. If we have an await, it needs to be inside of an async keyword, and if we call an async function, then we need to await it. So let's take a look at some sample use cases of how we might use async and await. We saw that hello world mechanism, and the cool thing is this asynchronous method will just go do the things that it needs to do. Now we do need to kick off that process, kick off the asynchrony, and so we'll do an asyncIO.run. Now we'll probably do this at the beginning of our program just to kick off the event loop and get it started running asynchronous tasks. If we just called main directly, it wouldn't actually have that event loop running, and our asynchronous program wouldn't run as expected. But we saw how this program worked out really well. We can just sleep for a second, and then once we're done, we'll continue on. Let's take a look at another use case. Now in this case, we're looking for a database call. So we'll grab asyncIO, we'll also grab IO MySQL, and so now we can do MySQL database calls asynchronously. So we can see lots of awaits here where we're creating mechanisms where that process may take some time. This is excellent. We don't know how long the database is going to take to execute this command, so we'll just await it. And then we'll go grab the next row, and we can validate that that works as expected. We also close the pool, close the connection, and wait for that connection to be closed as well. So we'll asyncIO.run that to be able to kick off the event loop, and now our database connection will run asynchronously. Perfect. Now, most of the time we will use the async and await keywords. And probably most cases that will be completely sufficient. But what if we need a little bit more? Let's look at some use cases that might be a little bit more advanced where we might use other primitives. As we talk about these, we'll talk about some other keywords here in this mechanism. A coroutine. Now, this coroutine is a function that has async def at the top of it. So it's not just a regular method, but rather, well, an async method. Now, we can talk about a coroutine object, the results of calling that method. Then we have a future. A future is a promise of a future result. In JavaScript, these are called promises. In Python, they're called futures. Now, this promise of a future result is the results of calling asynchronous coroutine. So that coroutine object, we can think of that as a future if we wrap it nicely. And so the way that we'll wrap it is in a task. If we take a coroutine object and we wrap it in a task, now we have a variable where we can check the status, see if it's done, and get the result once it's done, and even cancel it. And fourth, we'll have the event loop. The event loop is the process that keeps track of those asynchronous processes, and once they're done, it calls into that callback, returning the results of that state machine. So we do need to kick off the event loop, but for the most part, after that, we'll forget about it. So let's take a look at each of these things. We have a coroutine that is an async def function. We have a future where we get the results of it. Notice that this is a runtime error, so that won't actually work, but that's actually the result, that future. We can async io.create task, wrap that future in a task. So now that we've got the task, we can either await it or cancel it or check to see if it's still running. And then finally, the event loop. We need async io.run to be able to kick off that process. We'll probably do that exactly once in our application just to ensure the event loop is running, and then everything else we'll just use async and await, or we might use create task. Notice though that with that task we can still just await it to be able to get at the result. Coroutines, futures, tasks, event loop. Yeah, the majority of the time we'll just use async and await, and we don't need to worry about any of these. So let's talk about interop with existing code. Now, most of the time, we'll have those rules that say if we call into an async function, we need to await it, and any function with an await in it needs to be an async function. But, well, what about some of the extra things? If we have a, say, main function, we need to be able to kick that off. And so we'll use async io.run to be able to start that event loop and get that started. For example, here's a main function and it calls into my function. So it needs to kick off this asynchronous process, but then it wants to go do the other main things. Now in this case, we didn't await it and we didn't async io.run. So this process will start, but it will not continue. We'll start running, we'll do this async io process, but we never check to see if it's done. So this line at the end never runs. So that's definitely not the right way to do it. Instead, the right way to do it here is we'll do an async io.run, and now it will do the thing, and then it will finish running this main method, and then it'll finish sleeping for a second, and then we'll get still run at the end. Let's see if we've got a sample for that. Async io from sync. Yep, here we go. We're going to call into that function and then ultimately finish. So Python 3. We can see how it runs. It's still running, and main is running there too. So we've kicked off that asynchronous process, and then we can continue on doing the other processes that we need to do. Excellent. Now, probably we don't need to worry about the event loop other than to make sure that it's running. So calling async from synchronous code. The best rule of thumb is don't do it, but we probably do need to do it once to get our code started. The benefit of just awaiting it is that we get the results, we get exceptions if any of those happen, and all of that just happens in line. By comparison, if we call asynchronous code from synchronous code and we just say async io.run, then we don't get those results, we don't get the return codes, we don't get exceptions caught. So we do need to kick off the process. So we'll probably say async io.run main, and that will kick off our event loop and ensure that everything else in our application can run asynchronously. Why do we need to do this? Because we can't async the Python executable because that's really not how that works. So instead, in the top of our program, we need to async io.run our main method. Great, now that we've got that event loop running, everything works great. So let's take a look at some other advanced techniques where we might want to take a little bit more control over our asynchrony. Now here we're trying to do two things at once. We have this do work function that will sleep for a specified amount of seconds, we'll print messages before and after, and we want to launch it twice. Let's launch it first for 2 seconds, then let's launch it a second time for 1 second, and we'll await in both places. Now, if we launch this sample, we can see that we've got that waiting for 2 seconds, waiting for 1 second. So let's Python 4. The total execution time of this application is 3 seconds. We waited for 2 seconds, and then we waited for 1 second. These things didn't happen in parallel. Now, our application did yield to accomplish other work, perhaps, but because we're awaiting these straight away, they're not running in parallel. Let's take a look at how we might do this a little bit differently. So let's have this do work function, and let's asyncio.createTask. This task now lets us handle other things. So we'll launch the first one, the 2 seconds one, we'll launch the second one, the 1 second one, and then we'll await both of them separately. We've launched both of the processes, they're continuing to run, they're continuing to wait for their results, and now we'll wait for their answers. Now in this case, we're waiting for the second one and then the first one. We could do that in another order, we could await an array of tasks, but we'll see here, Python 5, that now the total execution time for this program is 2 seconds. It doesn't do them one after another, it does them both simultaneously. Well, kind of. It context switches between them. So how might we do this if we wanted to do a whole lot of things? Well, here's another one where we do that same wait for a certain amount of seconds. And so now let's kick off the 2, let's kick off the 1, and then we'll asyncio.gather. This will take an array of futures and turn it into an array of results. Once it's done, we can just await that asyncio.gather. So now let's do this, Python 6. And we can see that we'll kick off both of them, we'll wait for them. Now in this case, 1 was done first and then 2 was done. That's totally fine. And so our total execution time was 2 seconds. Now, should we use asyncio.gather or should we just await the 2 of them? That's definitely personal preference, but ultimately it yielded the same result because we said create task and kicked off both of the processes and then came back and awaited them, then they ran in parallel. Alternatively, we kicked off and gathered them in the same spot and got our array of results. So when we kicked them off and then awaited both of them after that, it did work in 2 seconds rather than just in 3 seconds in our original example. And here's that other way of doing it, asyncio.gather. So how do we gather these results? Well, whether we're awaiting multiple things or whether we're doing asyncio.gather, the rule of these tasks is that it will succeed when all the tasks are complete, or it will throw on the first error. So if we called do work and one of these do works failed, we wouldn't continue waiting for the other one. We would just immediately throw that exception, and then we could handle that error elsewhere. So what if we only want to wait for a certain amount of time? So in this program, we have our do work that will sleep for a certain amount of seconds. And so let's call that do work and have it sleep for 10 seconds. But then let's say asyncio.waitFor. So it's going to run it, but it's going to time out after 2 seconds. If after 2 seconds this program doesn't finish, then we'll get an exception, a timeout error. But if it does finish in time, then we'll just continue running. So let's run that one. Here's this program where we're going to wait for we'll launch it for 10 seconds, but only wait 1 second. So Python 7. We can see that we launch it for 10 seconds, we wait for 1 second, and we gave up waiting. We ended up here in this exception. Well, what if we do that a little bit differently? Let's launch it for 1 second and wait for 2 seconds. Now, if we launch this program, we can say that we finished waiting, and so we didn't throw an exception in this case. It finished in time. This can be great if you have, say, a long database call or a long API call, and you're not quite sure if it'll finish in time, and you want to provide a good user experience. Now, it doesn't actually cancel that work. It just gives up waiting for it. So does that work continue? Maybe. Will the task complete even though we're not waiting for it? That's not deterministic. If our program exits, maybe that thread gets aborted, or maybe we're closing a socket and then the server may not notice. It's not deterministic. Will it finish? Will it not finish? Yeah, because it's not deterministic, we should probably not use this for updating data. Let's take a look at canceling the task. Here we're going to want to abort that process to make sure that it doesn't finish. We have that same do work function that will sleep for a certain amount of time. And so now let's create that task, and then let's wait for that task. But if we don't want to wait long enough, then we'll call task.cancel to abort that work. So let's take a look at how that would work. Here's canceling the task. And so we've got that create task. We'll wait for, notice that instead of just calling the method straight away, we've already wrapped it in a task, so we have more visibility. We'll wait for 2 seconds. And then if we give up waiting, which of course we're going to do, we're going to give up in 2 seconds instead of waiting 10, then we will cancel that work so it won't continue. Python 8. So we launch our task. In 2 seconds, we cancel it, and now we've exited doing that work. Now, how about that thing? Is it done? Did it finish? Is it going to get stuck in the middle? Are we going to end up in an indeterminate result? Well, yeah. If we cancel the task, how far along the road did it get? Did it add all the rows? Did it only add some of the rows? Did it change all the data? Did it not change the data? It's a non-deterministic result. And so, especially if we're calling into an external API, then that external API may do things completely differently. Will it notice that we've closed the socket and end that work? Will it end it in a good state? Ultimately, it's probably best for us not to cancel a task unless we know that that task is running a pure function. It's only querying data, not updating data. If we're updating data, we probably should not cancel. We should probably see that through so that we get a deterministic result. Ultimately, if that's going to throw an exception, then we know that that update did not complete. But if we have a pure function, if we have a GET request, then perhaps we can cancel if we're tired of waiting for those results, or if we have a new query that may replace the old query. Async IO. Async IO is a great library that allows us to think synchronously and run asynchronously. That's really great. It allows us to get the best of both worlds with asynchrony. We can code asynchronously, but we still can reason about it as if it was a synchronous program. We just decorate our code with async and await, and we're able to take advantage of it. Now there are additional scenarios where we can dig deeper into running parallel tasks or canceling tasks, and those are definitely available to us. And Async IO is built in. Thanks for joining us here for Pyjamas. This was fun to dig into Async IO inside Python. The slides and the code are online right now at robrich.org. And I'll join you in a moment for that spot where the conference is designated for live Q&A. Or if you're watching this on demand, hit me up on Twitter at robrich.org and let's continue the conversation. Thanks for joining us.
All right. So, thanks for Rob to Rob for his amazing talk about async Python, and we invite you all to join us on Discord and continue to join at the Pyjamas conference. So we continue with more, and now we have Jay Miller who will give us his talk about building Twitter campaigns with Azure QoS, where he will tell us about sending tweets with Azure and TweetPy to automate that process. Jay is a senior cloud advocate at Microsoft, based in San Diego, CA, a multi-potentialite. Sorry. Jay enjoys finding unique ways to merge his fascination with productivity, automation, and development to create tools and content to serve the tech community. So, here we have Jay, and yes.
Hey,
Hi, Jay.
how's it going? Can you hear me?
Yes.
Perfect.
So, how are you?
I'm doing great. It's a quiet Saturday evening, so I'm looking forward to sharing some of the stuff that I did over the last few months, and happy to connect with people.
Really, really nice. Where are you joining us from? I don't know. What time is there?
I'm in San Diego, California, so it's 6 p.m. here.
Great. All right. So, Well, Jay, the stage is yours.
Sure. Let's see if we can get our screen shared, and then we'll be ready to take off. There we go. Actually, I just realized we're on YouTube. We don't need closed captioning. There we go. Full screen. I like that instead. Hi, everybody. I'm Jay Miller. As was mentioned before, I'm a senior cloud advocate at Microsoft. I focus mostly on Python things. Well, and not sharing my slides, apparently. Let's try that again. It's not wanting to work. There we go. Perfect. So, yeah, I decided to take on the fun and fantastic challenge of not only building a Twitter bot, but building a Twitter campaign. You might be wondering what the difference is. This wasn't its own Twitter account. This was me allowing the internet to send things on my account, which is dangerous, but also it was a lot of fun, and we did it in the safest way possible. And I want to break down a little bit of how we were able to do that. But the first step was why. October is, in the US at least, it is ADHD Awareness Month. It is a month where folks who have ADHD, like myself, hi, I have ADHD, PTSD, and general and social anxiety, among a slew of other things. But it's a time to recognize those individuals and encourage other folks to consider seeking a diagnosis if they think that that would benefit them. So I did this survey through a series of Twitter Spaces and blog posts and many other things, even a couple of conferences. Last year, I actually spoke at this conference about some of the things that I had learned from other people with having ADHD, and I wanted to share that with the world. So I decided to take the anonymous messages of encouragement that people had filled out via survey and send a message once a day anonymously, on my Twitter account. And it was a great experience and a great campaign, and I hope that it made an impact in some folks' lives. So for this talk, we're going to be addressing Twitter's API. Don't worry. We're going to be talking about Azure storage queues and how I use them. We're going to be talking about some of the benefits and drawbacks of using them as well, and figuring out what is ultimately the best plan of attack for this, and also maybe even start to think about some different ways to use these queues as well. But I don't know if you've noticed lately, Twitter's kind of in a weird space right now. Yeah, it's complicated. I chose to do this. I'm actually still on Twitter, but obviously I have my own concerns. But one of the biggest ones is getting access to Twitter's API. So I will tell you, in order to do what I did, you will need access to Twitter's API. But also, even though Twitter's API plays a big role in this talk, it's the way that we've designed things. Hopefully it doesn't mean that it has to be the only way that you can use this. So if Twitter's not your thing, insert other service here and roll with it. But for us, Twitter's the thing. If you wanted to do this, you would need two different pieces of access. One that is free and has no review required, and that allows you to send text. I believe you can also send things like Twitter polls, and it gives you access to Twitter's V2 API, their newer API. If you want something like storing assets for like videos or images and you want to tweet those things out, you do need to request access. You can use these QR codes. I'm going to give a little bit more time just to make sure that people have selected those if they want to. You'll have to ask for that. It took me 24 hours to get access. It took one of my colleagues about 15 minutes. Again, I don't know how to help with that. All I can say is fill it out. The next thing you'll have to do is you'll have to set your access tokens to read and write. I'm going through this really quickly. There are a lot of great demos on how to build a Twitter bot that go through these steps. But if you've never done it before, and sometimes Twitter's policies do change, I just want to make sure that everyone is on the same page. What you are going to need are those consumer keys at the top, the API key and secret. And you're also going to need the access token and secret. But by default, your access token and secret are for read-only permissions. And the only way that you can get read and write permissions is to generate OAuth 2.0 client ID and secret, and then regenerate your access token and secret again, and it'll be recreated with the new permissions. And then you might be wondering how we actually access the Twitter API. We've talked about how you get access to it, but once you have that access, how do we actually utilize it? And you use Tweepy for that. Tweepy has as much confusion as Twitter's API does. To use the V1 API, you're going to use the API endpoint, and it's the OAuth 1 user handler. That gives you access to version 1. If you need to use version 2, which you will, you need to use the client endpoint. And then you can use the endpoints in however you choose to, and we'll talk about how I did it in just a second. So that is the walkthrough on getting access to the Twitter API and utilizing it via a wonderful tool called Tweepy. You can get pip install Tweepy, and that will allow you to send tweets and read tweets and follow, unfollow, DM, block, report, do all the things you want to do using Twitter's API. So that's only that's only a third of the story. The second is learning about these things called Azure storage queues. And what is a storage queue in general? Before I get into the technical aspect, I want you to think about what a queue would look like. Let's say if you're in the US, you're at the post office and you have a package. And you're waiting in line with your package, and then, next person in line, next person in line, next person in line. Finally, it's your turn. And they say, well, what would you like to do? And you give them all your information, and you give them the package, and you pay for shipping and postage and all that. And then you walk out the door only to see that you left a letter in your car. Well, then you have to go grab that letter, and you walk back in line and sit down. And yeah, you do the whole line thing again. You go get in the back of the line, and you wait until you're all the way back in front again. And then you go through that process again. And then you can finally leave when you're done. This is kind of what storage queues are. Instead of being a database, they're actually a storage object. So they sit in kind of a cloud storage, a cloud blob storage, and they're in a queue. And what you're allowed to do is you're allowed to have thousands, tens of thousands, hundreds of thousands of these items in queue, and they'll be given an ID, they'll be given a queue count, which is important, and then they'll be given their content, or basically what they have to deliver. And then there's also an expiration date, so if let's say that the item took too long, then it goes away and just kind of disappears. So when the person calls next in line, instead of being deleted, what it does is it immediately goes back to the end of the line by changing its DQ count. So then it'll go to the next item. And same pattern occurs. And it'll say next in line again. And then it goes back up to the front because everyone has been served. Now, if you tell it to delete afterwards, it will actually do that. So then when you say the next in line, it does the thing. And then after that, all that's left is that second object, the one that hasn't been done yet. And then once the queue is fully exhausted, it's fully exhausted. So I've talked about kind of like that package, that item, that content that gets passed in. What is valid? So the things that are valid are either encoded bytes, strings. They do have to be UTF strings. I think if it's encoded bytes, it has to be ANSI. But the nice thing about that is because it's a string and because it'll accept UTF strings, we can use JSON. So don't think about it as just a simple message. Think about it as an entire payload that you can pass in to your content piece. So how do you set up these Azure storage queues? Well, the first thing you have to do, and I have a little video here showing you, you're going to have to create a resource group. This is using Azure's CLI. That way, if you're on Mac, PC, Linux, you can just install the CLI. But again, you're going to create your resource group, and then from there, you're going to create a storage account. There are other ways to do this. This was the easiest one that would fit on the slides. If you want to learn more, there's a link there on how to create it. It's 2 commands. And then you're going to need to go and get access to that queue. Notice we just created the storage accounts. We didn't even name our queues yet. So when we do that, there is a little command that you can run that says, oh, I'm sorry. I don't think I actually added the queue, the actual command for the queue. Oh, yes, I did right here. Azure storage account show connection string. That is the command that you can provide. It'll give you this really long connection string endpoint that you can copy. And then inside of Python, you can pip install azure.storage.queue. And from there, you'll import azure.storage.queue. And then you can have a queue client, and you'll use the class method from connection string. And then you give it your really long connection string that was here, and you give it the queue name. And from there, you have a queue. You have a segment of objects that allow you to, create your line. Now, once you're there, you need to add to your queue. You add to the queue by providing a queue message. Or sending a message to the queue. Now, I actually had a function that said queue message, and we'll talk about that a little bit later. But from there, you can basically just loop over the items and tell them to all get in line, and that's what I did. I had a list, a CSV list of all of these items that needed to live in the queue, and I just said, hey, enumerate through this list. First, try to create the queue to make sure it exists, and then if it doesn't exist, create it. If it does exist, then that's okay. And then we're going to send all those up. But if you notice here, I'm passing in kind of this little strange message of like index and in message and things like that. Don't worry, we'll get there. It'll all make sense in the future, I guess. So once we add to the queue, we can then pull from the queue, and when we say receive queue, what we get is that same JSON string. We get that same index, the index number, and then the text and all of that, and that's all inside of our string. So that's the message. Now we're doing like receive message. Technically, it's actually like it's queue receive message, and then some. You want to get the content of it, and that's what would return this JSON string. So this is actually queue receive message dot content. So if you noticed in the original picture that I actually had an image. I don't have enough time to talk about how I made that image. I will tell you, adding text overlays onto images are hard if things change. The image itself always stayed the same. The actual text was a variable links, multiple links. So some were like 500 characters, some were like 40. So basically what I had to do is I had to create this pattern that said, between this number and this number, if it was there, then make it this width. If it was there, make it this width. If it's there, make it this width. And then basically scale up as large as I possibly could until I hit the boundaries that I had set for the image. But if you look at this image here, that number 18 is actually the index that I passed in at the beginning, and the text is the actual text that was there. And then the 31 Days of Neurodivergence was just the campaign name that I gave it, so I would know where it came from. So we've kind of talked about 3 main components to this, and there were kind of 2 that were really important. That was the first one, which was interacting with Twitter's API, which we didn't really have to talk too much about because we're gonna wrap it up in just a second on that. And then we had this whole concept of storage queues. And if you notice, there's a lot of individual things that you have to keep track of. You have to keep track of your API keys. You have to keep track of your queue name and your connection string and all those things. I actually showed this to my team and they said, well, we could make this a little fun. And what we did was say, well, Azure Storage Queues plus Tweepy equals AZQTweeter, because naming is fun. And what AZQTweeter does is actually allows you to store those values either in environment variables or directly. And then you can just pass in one object that says QTweeter. And as you are interfacing with that, it is sending those commands behind the scenes. So let's look at our order of operations here. The first one that we have is receive message, which basically says, hey, what is next in queue? And then we want to do our message transformer, which is going to give us all of our Twitter arguments. And those Twitter arguments are what's the file name, so that we could take our newly created image and upload that to Twitter. And then from there, when we send our tweet, we will embed that file, that media ID, because Twitter requires you to upload the file first, and then send a tweet referencing the file ID. And then once we're done, we have to send that delete signal. Remember, Azure Storage Queues by default will not delete your content. It will just move it to the back of the line and make it, technically it'll make it invisible for a period of time that you have to set, or I think by default it's like 30 seconds. But once you tell it, I want this to delete, you send that pop receipt. Again, this is a lot of things. With AZQTweeter, we clean it up just a little bit. We create our little function. This is our message transformer. We say we want this content to be these things. Here's our file name. Here's our file so that we can reference it. And then when we trigger our message, we want it to say send next message. That's it. The message transformer is the function that we provided up top that gets thrown into a Lambda that gets ran. Preview mode is false because we could tell it, hey, we just want to see what the next message would be, and it would show us that, but we say, no, we trust you. And then lastly, we're going to delete the message after. In this case, we didn't delete it, and I will explain why we didn't delete it in just a second. And the end result is you get an object on Twitter. Now, unfortunately, I'm looking at my slides here in my camera, so I can't really see if there were any questions, but I do wonder if someone said, why would you not just use a database? Why would you not just use a JSON file? Why would you not use an ETL pipeline? One, ETL pipeline is very expensive. I would not suggest that, at least not in this way. But you're right. Why would I not use a database or something like that? Well, one simple answer is cost. In most cases, your database will make up the largest portion of your actual costs, your operating costs. And for me to run this campaign for a month, it cost me a total of 6 cents because I used Azure Storage Queues instead of a traditional database. I have also tested this in a database and it's greater than 6 cents. We'll just say that. But as you can see, I used Azure Functions to run this on a cron job, and that cost me less than a penny. Also, I was able to do threat protection to check my images. I was able to, pay the cost of bandwidth. All in all, I would say I think it would have cost Azure more to bill me than it did for me to actually run this service, which means I can scale it up significantly more than other resources. So, as we get ready to wrap up, I do want to talk about that idea of an ETL. While I don't think that this could replace an ETL at all, I do think that this could serve as your own little personal ETL. In fact, I encourage you, make it yours. If you want to do something like this, don't do a manual input. Automate the input. Use things like GitHub Actions to bring items in, like we're doing with our podcast, so that we can send out tweets whenever we get new content to talk about. Use things like RSS to automatically post to federated services when you publish to your blog or when you create a new YouTube video. Your automation layer can be entirely up to you. As long as you can wrap it in a Lambda function, then that's perfectly fine. Just be sure to throw it in that message transformer. And then take that desired output and send it wherever. I send it to Twitter. You can send it wherever you'd like. But ultimately, it's up to you. And if you have any ideas, be sure to let me know. We're actually working on scaling this up so that it can do more than just send tweets. There's going to be a lot of work there. But if you want to help with that work, there's the repo there. It's az-q-tweeter. The name will probably change soon. So be sure to follow me on Twitter at the moment. At KJY Miller. And of course, you can reach me on my website. It's right there, and just go to /contact, and that'll send me an email. And that being said, I want to thank you so much for coming to my talk, and I hope you have a fun time automating your Twitter experience.
Well, thank you, Jay, for your excellent talk. It was very interesting. So, yeah, thank you so much for that. And we'll coming back for more. Yes, thank you so much.
Thank you very much. I don't know if the questions in there were...
Yeah, it's a question that says, well, are you sorry. Yeah, but I think there's no questions.
Okay. I can answer that one. While I do have an account, I am not currently on Mastodon. I don't have any problems with it. I'm actually taking this time to kind of stop consuming as much social media and actually start producing things for it. So
Great. Well, I think that's all for you. There are people clapping for your talk.
awesome.
And yes, thank you, Jay. It was very interesting.
Thank you. Here.
So, bye. Thank you.
Hello. Welcome back. Hi. So yeah, now it's very exciting for me because now it's like in the middle of the night. It's like 3 a.m. 28 for me. So I'm still alive. But we have our next talk very soon. In a few minutes, we will have next speaker giving a talk about the observant developer. So how to be observant. I really want to know. So, but before that, I have a few announcements to make. For example, we have a raffle. So, the raffle will be closing an hour before our closing. So, fill the form as soon as you can. If you haven't got a ticket, register for a ticket. And so that is the link for you to enter the raffle. Also, we have our next host here. So let me introduce our next host, and then I will let him introduce our next speaker. Hello.
Hello. How's everything?
You good?
Yeah, I'm good. I'm good. I'm perfect. It's not the middle of the night for me. It's just 9 p.m., but I'm very excited to be here. Um, this is something I ever wanted. I had pajamas, being able to host a session during the middle of the night for some folks, or very early in the morning for other people in around the world. So thank you for the opportunity.
Yeah, that's really cool. So I will let you introduce our speaker, and I will just slowly move away.
Yeah. So thank you. Sure. So our next speaker, Ronnie Dover, he's gonna come. They're gonna be talking about observability. Ronnie, welcome. Happy to have you here.
Hi, great to be here.
Uh, so whenever you're ready for your presentation, let me know, and I will just leave the stage for you.
I'm definitely ready.
Okay. So good luck, and again, thank you very much. See you in a moment.
Thank you. So, hi everyone. I'm extremely excited to be speaking about what's become kind of my favorite topic, which is open telemetry and continuous feedback and other topics. And the reason I'm so excited to be speaking about it is I think because there are such few times where you can see how technology can really make an impact on how we write code to the extent that it changes it. I've seen that happen with testing, with async development. There are these concepts where you can see they start seeping in, and eventually, everybody's coding a little differently. And I feel that these specific technologies have the potential to do quite the same thing. And I hope that by the end of the presentation, you'll kind of agree with me on the potential at least. So let's get started. So just about me, I've been a developer for over 20 years. I've also been a product manager and kind of oscillated between these two extremes. It's been very hard for me to write code without caring about the why and the requirements. And it's been equally hard to worry about user stories without getting my hands dirty and actually writing code. So eventually I managed to somehow resolve that inner conflict. But from both these kind of ends, I've seen and have been obsessed with how do we actually improve the development process, and how can we, and I'm very kind of skeptical and evidence based in my approach in seeing, okay, what works, what doesn't, which parts of agile work, which parts of other technologies work, how can we make things better. And it was throughout that journey that I stumbled into a little issue, I think, with some of the dev process that we use today that I want to share with you, and kind of show how I think it leads up to more observability as a very important kind of cornerstone of development. So to illustrate that, I'm going to go through kind of a story of a developer in my team called Bill, a very hypothetical developer. Bill is really, top-notch, best developer in the team. He's been doing it for a while, and he's been tasked with something very simple that I think we've all been tasked doing in the past, which is take this feature, develop it, and then get it all the way to production. And over the year, Bill's job kind of shifted, right? Because, I remember when I got started about, 20 years ago, creating a feature actually meant developing it. So, you would finish developing it, you would wrap it up real nicely, And then you would hand it over to the guys across the hall from the QA team, and they would take a look at it. There would be some philosophical arguments ensuing about what's a feature, what's a bug. But eventually the feature would roll on and you would forget about it, except if it has a bug or something, and then you might be hearing about that feature again. But that was where your involvement ended. And of course, that's no longer the case. It hasn't been for a while. So today, developers are owning the feature. So they're owning unit tests. They're responsible to make it maintainable, to make it something that can be scaled later on. They even know how to deploy it oftentimes, so they understand Helm charts and Terraform and other technologies to allow taking features all the way to production. And Bill has been the same way. So today, when Bill rolls out a feature, he's, again, top-notch of a developer. He's doing everything right. The GitOps process, test, actions, everything. But the question remains, what happens then? What does Bill have to do a minute after he clicked that button to merge the pull request? Everything, continuous deployment kicked in. Everything is in production. What should he do next? And the truth of the matter is that 99% of the time, despite my best efforts, and my expectation of Bill was check if your code works. Does it work well? Is anyone using it? Did it change anything? You merge this fix into this very important data access layer component. Did it improve things for everyone? Are things slower now? I've seen meticulously written code being pushed to production, and we would only discover like months later that it was one bad if statement away from actually getting executed. Just because somebody, made a mistake and nobody checked. So what I want to happen is for Bill to own his feature all the way to production. But 99% of the times, what would happen is that Bill would just move on to the next story. And this I've seen repeated across multiple teams and multiple companies that I've worked with. And it kind of made me think about the fact that we have this concept of this infinite loop where things are being built and then integrated and then deployed and then operated upon. And we have so many tools. This is just a random pick I got grabbed online. You'll find numerous examples of the same kind of diagram. But I challenge you to see, there is something missing here in this diagram. And if you look real closely, you'll see that each of the stages that are in this diagram have multiple tools associated with them, except for one. So for some reason, continuous feedback seems to be a really important part, right? It's what's supposed to bring all of these insights back from production to development, has only one tool associated with it, and that's Salesforce for some reason that I still haven't figured out. But the important thing is that there is a kind of a big gap here in the DevOps loop. And this gap is not theoretical. It is something that I see every day. Developers are moving on to the next feature. There is no kind of continuous ownership of the feature as we shift, right? Beyond testing, beyond deployment, and into, okay, so how does this work in production? Did it actually make things better for everyone or not? And this is very indicative of the way our feedback, or the feedback that we have, is in general. So, we have great feedback when we code. The IDE has tons of features and watches and breakpoints and all of those things. We have, I would say, so-so feedback when we're running tests, because it's just yes or no questions. Did the test pass or fail? Less qualitative, if you will, but it's still feedback. And yet we have almost no feedback from production environments. And this led me to think, again, both as a product owner and as a developer, well, if only we had more access to instant objective data about our code and how it worked, and being very evidence-based in how I thought, well, yeah, this would be ideal if I could say to Mr. Bill, look, here is the data, and that's it. And then he would be able to use it. And that's the perfect segue to talk about open telemetry and why I think it's very significant. So open telemetry is a lot of things. I don't think it's groundbreaking in particular. It's not a completely new technology that reinvented the wheel or anything like that. But still, I think it is one of the most important technologies we have today. And the reason for that is that everyone agrees on it. And that could not be overstated. So the fact that there's a consensus about a single observability technology that is both open source, open standards in terms of anybody can take a look at it, and open telemetry is just a spec to tell us about how to take measurements of how the code works and take traces and take logs and things like that, has just led to two very important consequences. The first, as you would get with any open technology that becomes widespread in the market, you start getting an ecosystem. So suddenly it's not just the vendors or the kind of proprietary technologies that can provide value add tools, everybody can. So suddenly there's this entire ecosystem of, well, there's this data and here are 10 or 20 open source tools that can help make that data more valuable. The other aspect is that because you don't need to kind of split your effort between the Splunk way of doing things and the Datadog one or the New Relic one or the App Dynamics, I'm trying to keep track of everyone and not and be fair to all of the observability IPMs out there. But because you don't need to worry about supporting each and every one of them, it just becomes very easy to incorporate support for OTel in your platform. And that's exactly what happened. So today we're at a situation where I think there is this unprecedented coverage, and no matter the tool that you're using, and no matter if you're using, let's say in Python, if you're using Flask or if you're using Fast API or if you're using Django, it doesn't matter kind of the database or queuing or other platforms that you're using, most of them are going to have built-in support for OpenTelemetry just because it's a very easy decision to make as a project maintainer to include support and instrumentation for it, or just for somebody to go out and develop a package that supports that. So to illustrate that, I've created a sample solution, and you can find that in this link. I had two goals in my sample solution. First, I'm kind of allergic to these CRUD apps that are very, very thin, paper thin and non-realistic, where you just, have create, update, delete, and that's it. That's the app. And I thought observability, to really illustrate the value, needs to be something deeper. So I created kind of a fake API for the Gringotts Vault from the Harry Potter Wizarding World. For those of you who are familiar with it, the reason is I was watching the movies with my kids at the time. And throughout making that application, I challenged myself to see, well, I'm making a completely new application. I'm going to use Fast API, Rabbit, Postgres, some worker service, maybe some related packages. Let's see how easy it is to indeed take all of that information out of the application without spending a lot of time rewriting the code. And my goal was, how can I, as Bill again, get complete visibility into what's going on? And maybe for that, we can just take a moment to just explain these two basic concepts around tracing, which is a big part of what OpenTelemetry offers us. So a trace, for those of you not familiar with it, is basically a flow that goes through the system. If the user hits the API, then a message goes into the queue, then the service does something that uses Postgres and maybe some external API. That entire request flow is considered a trace. And then within each kind of segment, you can break down each individual activity, and that's called a span. And my challenge was, well, how can I get these traces and spans information about this entire application, we'll see that in a sec, without making too many modifications to the code? And it so happened that almost each and every one of the technologies I was using in this particular project already had support for OpenTelemetry, and it's not by chance. It's kind of, as I mentioned, the situation. And as a result, with Fast API, I got fast instrumentation working. RabbitMQ, I used Pika, for those of you familiar with it. So I got Pika instrumentation. And all of these instrumentations, and I'll show you that in a sec, are pretty much just type instrumentation.enable, and that's it. And you have data. And there's ways to even make that automatic. But once I've activated all of these data points that you see here, without making almost any code changes, my situation as Bill, the developer, changed from having zero visibility into what's happening with my code in production to having, you could say, too much visibility or too much data about how my code works in production. And because we also have some awesome open source tools, visualizing and seeing that also became very, very easy. Now, this is a very short session. I don't have a lot of time to go into the, let's try to do something. So as I mentioned, getting all of that information out is very simple. You can kind of see here the different instrumentations I use that are just packages that are part of PyPy. And I just added these packages, and then you just add, let's say, for logging, for request, for Fast API, for each of them, you just call the instrument API, and that's it. And basically, it's already sending out data. And OpenTelemetry also comes with a very easy way to configure where to send that data to. How do you call this kind of source where you're getting the data information out? In this case, it's the Vault service. And then configuring a lot of other things that really there's great documentation on, and I don't think I have a lot to add about, except to say that it's extremely simple. So once you've done all of that, you can get to the situation, and here is the API that we're using, and let's I don't know, trigger something here. So let's, for example, trigger an appraisal, which basically means that I'll send a Goblin worker to look for what's going on with a specific vault. Oh, I need to authenticate first, so let's do that. Perfect. And now let's execute that. And one of the nice and awesome open source tools that we have available is called Jaeger, and that's a great way to visualize the traces. Very easy to get a standalone Jaeger just from Docker or just install it. So no trouble there. And let's see what are the latest traces that Jaeger picked up about my service. And immediately I can see my appraisal flow or trace. And I can see that there are two services involved, the Vault service and the Goblin worker, that already kind of picked up the workload. And as you can see, it's very easy to get access into exactly what happened there. All of this information, again, was provided just by merit of enabling these automated kind of instrumentation packages. So immediately I can see kind of the specific DB statements that are going on here. I can see the specific API calls, and I can also see any logical instrumentations that I added to define spans. For example, I can take a specific area in the code and say, well, this particular area does X, Y, Z. Let's take an example. So let's say here I'm saying, okay, this is a span. I call it authenticate vault owner and key. And from that moment on, it's kind of logs on steroids that the application will monitor exactly what's going on with there. When it started, when it ended, who called it, a lot of contextual information that's missing from logs to provide me this very easy way to access what's going on with my code and what does a typical flow look like, and all of that really important information. And all of that is great. And it led me to think that, well, there is even more we can do with all of that information than just validate our changes after we've rolled them into production. So if you think about it, even before, this is a loop, right? So even before Bill got started on writing the feature, he could ask important questions. What is the concurrency around this code? Is it even being used? Am I over-optimizing here? Are there any issues I should know about? Maybe I'm going to fix some more bugs while I'm at it. What can you tell me about how it's being used now? And then before I code review it, again, I can ask a lot of really important questions to be able to plan out my changes better, review and evaluate my changes better. And then, as we said before, kind of understand what my changes did after I rolled them into production. So as you can see, this can have a very profound effect into how we develop code. So the question is, why is it not happening yet? And if I were to ask you, well, is that enough? If I gave you this information, would it change the way you code? And most of you would say, well, no, that sounds like a lot of work, which is exactly what I've heard from developers around why they're not using it more. Because I've been pushing my developers to use as much data as possible. And they came back with the answer, well, it's kind of hard. So let's explore that for a second. Why is that so hard? Why is it so difficult to practice continuous feedback? Well, the first difficulty is around expertise. So I just showed you a single flow going through the system, and that's interesting enough. But think about a production system where there are, potentially hundreds of thousands, if not millions of flows a day. How do we actually assess what's going on there? And that requires statistics and other kind of know-hows that we as developers don't always remember at the top of our heads. And it's not by chance that I put here a picture related to house repairs, because for me, that's my blind spots. I'm terrible at it, and I would procrastinate as much as possible anything that has to do with house repairs. And for exactly the same reasons, many developers would kind of push aside any task that has to do remastering Statistics 101 or understanding what's P95 or how to remove outliers or doing any types of analysis. The other aspect is that developers are very focused on one thing, and that is code. And if I need to context switch and kind of look around in other places, I'm kind of distracting myself from the main area where I feel productive. The next reason is that it's very reactive to kind of go around dashboards looking for trouble or fishing for trouble. And I think that's very interesting, because I think the secret is maybe in the name. The name is continuous feedback. That means that it needs to be continuous, right? Just like with tests, we don't actually need to stop and think, well, I'm going to run my test now. It needs to be continuous integration, right? And with continuous deployment, we don't consciously decide to roll out into production. It happens as a part of the pipeline we designed. Feedback needs to arrive continuously and as a part of my work. It doesn't need to be something I'm seeking out. Otherwise, none of us will, and none of us do. And this is where kind of my own personal journey with continuous feedback started. And I was thinking, well, I'm convinced. I think that this is really amazing data. And by the way, why do I know that this is amazing data? Is because developers do use it when things go wrong, when production is on fire, when the fire brigade goes out to fix an issue. We find out amazing troves of insurmountable troves of amazing things, and the data yields so many huge world mind-bending insights about the code. Oh my god, why is this slow? Why is this calling this? Is this loop always existed? How come I never noticed this before, right? So my goal was, how can we, knowing that there's so much information there, how can we make that information something that makes an impact on them? And to do that, this is my own personal journey, has been to create a project called Digma, which allows to analyze that data and make it a part of the dev cycle. And I'm very fortunate to have seen other tools do it as well. So I think the entire industry is going into this area. or new uncharted area where developers are kind of breaking the wall between the design time that they're working in and how production runtime works using observability. So to illustrate that, I just want to show you a quick glimpse, not because I want you to specifically use Digma. There are really many other great tools that allow to do that. I just want to show you kind of the vision of what I think future development is. So here is that same, and this is, by the way, why I'm excited about it, because I think development is changing. So here's the code for that API that I just showed you. And all I'm going to do now is just enable something in my IDE that will query a backend, Digma's backend, that just continuously analyzes all of that data that already exists, right? So I'm going to look at the same code again, only this time from kind of a new spectacles, right? And immediately I see stuff, right? This is very slow. There is not a lot of usage, but there is an n+1 query that was identified. And it becomes kind of a part of my work. I can see that this endpoint is slow. I can see, well, how much traffic does it see? I can see the bottlenecks, and I can find out that there is a specific problem with a query here that I should worry about, or a specific problem with a bottleneck. And all of this is information that becomes kind of instantly a part of what I'm doing. And if I need to see a trace or to go kind of deeper to understand exactly what's going on there, I can see that in context. And that's kind of the beauty of what this type of capability provides us. And this is how I finally am able to see Bill, as well as the other developers, start leveraging observability by making it a part of their world and a part of their code. So how do you get started? So I created this domain, continuousfeedback.org, and currently it's hosting a link with some resources that, some resources that I found useful that are mentioned in this talk and that you can start using as well, like Jaeger and OpenTelemetry and others, just to get started with continuous feedback and adopting these types of practices. And then more from an approach point of view, I think that the biggest part of what of the transformation that we're all going through is ownership. So, and I'm seeing kind of the same shift that we used to see with testing, where people were kind of kicking back or pushing back on the fact that they need to also test their code, and why is this my responsibility, and so on. And in a similar way, this is changing now with production. So owning the code all the way to production, use the tools, harvest the data that's there, implement a feedback into the dev process, introduce into your Scrum, have a weekly feedback meeting to see what do we know about the features that we rolled out, what do we need to know. And of course, you're welcome to reach out and join the thinking. This is a completely new area. There's lots of people who are active there, and I'm extremely happy to see it's coming alive. So please feel free to reach out to me as well. My contact details are also in this link. Be very happy to hear from you. That's it. Thanks for having me on this opportunity to talk in Pyjamas, and hopefully have everyone continue to have a great night full of Python and code.
It was a great presentation, Ronnie. I hope you all, everyone that is watching this live or anyone that is watching the recording later, take notes, because there's a lot of content in only 27 minutes. Ronnie, again, thank you very much for being with us. And I don't see. I see a question. I have a question for you. What is the most important thing in observability?
The most important thing?
Yes.
Using it. And I'll tell you why. I'm just saying that. I've talked to organizations, to people who did amazing things with observability. I've seen LCDs in the halls full of dashboards. And then I ask the person, well, are you developers using it? And they say, well, no, they think it's a and that's true. It's true. If we there's a lot of data. The secret is being able to use it.
Exactly. We don't do anything with data if we don't actually do anything with it. I don't see any more questions. Anything you want to say before closing?
No. Thanks for the opportunity, and I'm always happy to talk more. And hope the resources will also help everyone.
Yeah, we're very happy with your presentation. And folks, please continue. Our next speaker is going to be here in a couple of minutes. Ronnie, thank you again. Yeah, and see you in a moment. Hello. For our next presentation, there was a problem, and what we are going to be playing a different talk instead. So the presentation that you're going to be seeing right now is called Retro: The Magic of Self by Sebastian Self. This is a recording, but if you have any question, please feel free to pause the questions here, and we will make sure to move these questions to make this question arrive to the speaker. Hope you are all having a really good conference, as I am. See you in a moment.
Hello everyone, thank you all for joining the stream. I was planning on wearing my pajamas today, but it's really cold in here, so I decided to put on this crazy sweater instead. Still, I really like the idea of having a lazy conference from the comfort of my own home. Anyway, today I'll be talking about self in Python, and in doing so, I will introduce something called the descriptor protocol. But first, I'm going to briefly introduce myself. I am Sebastian, and I live in the Netherlands. During the day, I work as a Python developer and codesmith for the Ordina Pythoneers. I'm also one of the 3 owners of Python Discord, an online Python community. Together with about 100 volunteers, we try to provide a safe and welcoming environment for Python enthusiasts. But we also do things like organizing Python-related events or helping out other organizations in the Python ecosystem. Finally, I'm also a volunteer for EuroPython, another very amazing Python conference. If you haven't already, you should definitely check it out in 2022. Alright, that's enough about myself. So let's dive into the magic of self in Python. I'd like to start with something that Guido van Rossum said on Twitter a while ago. In a conversation about Python's many magical features, Guido said that, from day one, there was deep magic hiding in some places, designed to quietly help users. And it's true. This is why people say that Python is a very high-level programming language. There's a lot of magic in Python that abstracts away those pesky implementation details so you, the end user of Python, can focus on your business logic. You get a lot of very high-level interfaces to play around with, and you rarely have to worry about the logic underneath that makes it all happen. Some of this magic is of the very arcane kind, the kind that you and I, mere mortals, don't really get to play with, as it's hidden away deep inside of Python's internals. But a lot of that magic is not. It's there for you and me to play around with and to create high-level interfaces of our own. Today, I'm going to dive into one of the most magical things in Python, that when you call a method, you get the value for self for free. Without doing anything, Python has magically inserted the thing you called the method on as the argument for self. By diving into the magic of self, I hope to show you that magic in Python is not something to be afraid of. That you can pick it up and use it to write better software of your own. So, what is the magic of self? To make sure that we're all on the same page, I'm going to implement a very simple class. The class itself is not going to be very exciting or thought-provoking or pretty much do anything interesting at all. It's only meant to illustrate what the magic of self is. As you can see, I have a very simple class called guitar. The only thing it does for now is that if you pass a name to it, the dunder init method will assign the attribute name to whatever name you gave the guitar. This means that if I call my class like this, here I'm using the name of one of my bases, Warwick Streamer, I get a guitar instance and I can assign a name to it. In this case, I'm assigning the name Warwick to it, as I think that's a name that nicely describes what it is. Now that I have a Warwick guitar instance, I can simply get its name by accessing the name attribute. So far, nothing really interesting is going on, so let's add another method to this class. The method that I'm adding is a plain note method that will mock the guitar playing a note, as actually playing a note on a guitar with Python is quite hard. Basically, I can call the method on a specific guitar, pass in the note I want to play as an argument, and Python will print the name of the guitar, place the note, followed by whatever note I passed in. So if I call this method on my Warwick bass, pass in the note C#, the musical note, not the programming language, and hit enter, Python will print out the message, my Warwick Streamer plays the note C#. Nothing special, right? Well, if we zoom in on the function definition of the plain note method, we can see that something odd is going on. I know that I'm so used to adding it that it's almost subconscious, and in fact my IDE mostly does it for me, but this function actually has 2 parameters, not just one. It has a parameter I've called self and a parameter I've called node. But if we now look at how I called the method, you can see that I only gave it one argument, and it's clear that that argument, C#, ended up with the parameter node. So where does the argument for self come from? If you call a function, all parameters without default values should get an argument. Is this some kind of special exception? In fact, it's not, but something magical is going on. What has happened is that Python automatically inserted the instance, my Warwick here, as the first positional argument when calling the function. And this is the magic of self. Somehow, without us having to do anything at all, Python will insert the instance you're calling the method on as the first argument. However, while you may think this is some deep arcane magic that Python just performs for you, there's actually a well-defined protocol behind it, the descriptor protocol, that you can use yourself as well. And that's what I'm going to talk about today. But first, I have to explain what happens when you define a function within a class body. What exactly are methods in Python? To understand what methods are, we have to look at what happens when you define a function within the body of a class. As everything in Python is an object, including classes, if you're defining a class, you are creating an object of type. I'm going to represent that class object by this rectangle. And just to be sure, with object I don't mean the potential guitar instances you could create with this class, but the actual class itself, the guitar class. Now let's zoom in on what happens when Python gets to the function definition of the plain node method. Once again, since everything is an object, Python will create another object for you, a function object, an instance of the type function that contains everything there is to know about this function, including the code it has to run when you call the function. Now, since we don't really have a use for objects that are just floating around somewhere in memory, without a name referring to them, a function definition will also bind a name to the function object. Since we are defining this function within the context of a class body, this name will not just be a regular name, but it will be an attribute of the guitar class. In this case, Python will bind the attribute plain node of the guitar class to the function object in memory. However, it is important to note that our method is still mostly just a regular function object. But if our method is just a regular function object, what on earth is going on with self then? One really important observation is that we've assigned a class attribute to the function object. This may look quite innocent. Why would it matter that it's a class attribute instead of a regular name? But this is actually an important aspect of the magic of self. And to see why, we need to look at what happens when we access that function object using an attribute. Since we've assigned a class attribute to the function object, we can access the method as an attribute of the class, guitar.playNote. If I do that, you'll notice that I simply get back the function object. This is just a normal function object. There's been no magical insertion of self yet. That makes sense, since we don't even have an instance to insert as the argument for self yet. We're just accessing it on the class itself. Now let's see what happens when we access the playNote method as an attribute of an instance. First, I'm going to recreate my Warwick instance, and then I'm going to access the playNote method as an attribute of the instance. If you think about that, it's a bit weird. I just made a big point of saying how we've assigned a class attribute to this function, and now I'm trying to access it as an attribute on a guitar instance. So what's going on here? Well, this has to do with the way attribute access works in Python. If you access an attribute on an object, like I'm trying to do now on my Warwick object, Python will first look at that object to see if it has that attribute. If it does not have that attribute, like how my Warwick does not have a playNote attribute itself, Python will then move on and look at the class of the object. Does the class of the object have an attribute with that specific name? In this case, it does. But if it does not, Python will then look at all the other classes in the method resolution order, all the parents of the class, to see if they have such an attribute. So accessing an attribute isn't as simple as you might think. There's actually an entire lookup sequence behind it. And in fact, as we'll see now, what I just told you is a simplified version of what actually happens. Because if I now press enter and actually show you what accessing this attribute on the instance gets me, you'll see that I don't get the irregular function object back. Instead, I'm getting something called a bound method. And it's precisely this bound method that already knows what the value for self must be, the object you've used to access this bound method. So what is crucial here is the way in which we access the function. Did we use a class attribute or did we use an instance attribute? And this is because objects, like functions, can modify what happens when you access them via an attribute. They can hook into the attribute lookup process to modify what will happen by implementing something called the descriptor protocol. The descriptor protocol is what really powers the magic of self in Python. It allows objects to customize what happens when you get attributes, set attributes, and delete attributes. One important aspect of descriptors is that they're assigned to class attributes. So it's the object that you're trying to access that implements the protocol, not the class that owns the attribute. The descriptor protocol consists of 3 special or dunder methods. The dunder get method is involved in customizing attribute lookup, like simply accessing warwick.playNote. The dunder set method is involved in customizing attribute assigning, like if you assign something to warwick.playNote. And finally, the dunder delete method gets called when you delete the attribute that is assigned to the descriptor, like del warwick.playNote. Descriptors do not have to implement all the methods in the descriptor protocol. Instead, they can just implement the methods they need to do their work. As you've probably already guessed, functions are such descriptors. They implement the dunder get method to customize what happens when you get a function using an attribute. To get a better idea of how descriptors work, I'm now going to implement a simple descriptor that also customizes attribute lookup. For my example, I'm going to implement a descriptor for my guitar class. To make some room for it, I'm first going to collapse its methods, but you may assume that they're still there. The descriptor that I'm going to implement is the favorite descriptor. The idea is that if I access the isMyFavorite attribute on a specific guitar instance, this descriptor will tell me if that guitar happens to be my favorite guitar. For instance, if I recreate my Warwick instance and then access the isMyFavorite attribute on it, it should return true, as my Warwick bass is currently my favorite guitar. If, on the other hand, I create an instance for my Fender Jazz bass, the attribute should return false, as while this is a very nice bass guitar, it's currently not my favorite. Do note that I've assigned a class attribute to the actual descriptor instance, as this is how descriptors work. They customize how attributes work if you access them via an attribute. I'm not turning the guitar class itself into a descriptor. That wouldn't work. Alright, time to implement the descriptor class, favorite descriptor. Since I only want to do something special when we access the attribute isMyFavorite, I only have to implement one method, a dunder get method. The dunder get method has 3 parameters: self, which refers to the descriptor instance, instance, which refers to the current guitar instance I'm accessing the attribute on, like my Fender or my Warwick, and owner, which refers to the class that owns the attribute, guitar in this instance. Now, remember, I've assigned the class attribute to the descriptor. This means that in theory, I can also access the descriptor directly on the guitar class as guitar.isMyFavorite. Since there is no specific guitar instance in that case, Python will pass none as the value for instance. This is something that I will have to deal with, which I simply do by checking if the instance is none, and if so, by returning the descriptor itself. Returning the descriptor itself is not strictly necessary, but given that I have no other useful value to return, I might as well return a descriptor so you can easily introspect it. If the function makes it past this guarding if statement, I know that the attribute was accessed on an instance. So now I can simply compare the name of the instance to the name of my favorite guitar, Warwick Streamer. Obviously, this implementation is a bit naive in that it assumes that an instance always has a name attribute, but this is obviously just an example. Alright, let's see it in action. First, I recreate my Warwick instance. And then, when I access the isMyFavorite attribute on it, you will see that it returns true. What has happened is that Warwick was inserted as the argument for instance, and the guitar class as the argument for owner. Since instance isn't none, we make it past the first if statement and compare the name of the instance to Warwick Streamer. Since the name is Warwick Streamer, we get true. If I now also create an instance for my Fender Jazz Bass, you can see that when I access the attribute on my Fender, the attribute will return false, as the name of this guitar is not equal to Warwick Streamer. Finally, to complete the demonstration, if I access the attribute directly on the class, that is guitar.isMyFavorite, then I simply get the descriptor back. This is because there is no instance of the guitar class here, so Python will pass none for the instance. Which means that the function returns the descriptor itself in the if block that we have. Now, you might think that this is a really simplified example, that the dunderGet method of a function, the one that takes care of the magic of self, is much more complicated than this. In truth, as I'm about to show you, the dunderGet method of a function is nearly identical to the dunderGet method we have here. This is the implementation of the dunderGet method of functions, or well, a pseudo-implementation of the actual get method that was written in C. As you can see, it's nearly identical to what I just implemented for the favorite descriptor. If the instance is none, which happens if we get a function using a class attribute directly, this dunderGet method will simply return self, which here means the function itself. If we access the function on an instance, that instance will be passed as the argument for the instance parameter, which means that we make it past the if statement and then return something that is called a Py method. And this is the bound method we saw earlier. First, I recreate my Warwick instance. And then, when I access the isMyFavorite attribute on it, you will see that it returns true. What has happened is that Warwick was inserted as the argument for instance, and the guitar class as the argument for owner. Since instance isn't none, we make it past the first if statement and compare the name of the instance. Since the name is Warwick Streamer. Alright, let's see it in action. Hello everyone, thank you all for joining this stream. I was planning on First, I recreate my Warwick instance. And then, when I access the isMyFavorite attribute on it, you will see that it returns true. What has happened is that Warwick was inserted as the argument for instance, and the guitar class as the argument for owner. Since instance isn't none, we make it past the first if statement and compare the name of the instance to Warwick Streamer. Since the name is Warwick Streamer, we get true. If I now also create an instance for my Fender Jazz Bass, you can see that when I access the attribute on my Fender, the attribute will return false, as the name of this guitar is not equal to Warwick Streamer. Finally, to complete the demonstration, if I access the attribute directly on the class, that is guitar.isMyFavorite, then I simply get the descriptor back. This is because there is no instance of the guitar class here, so Python will pass none for the instance. Which means that the function returns the descriptor itself in the if block that we have. Now, you might think that this is a really simplified example, that the dunderGet method of a function, the one that takes care of the magic of self, is much more complicated than this. In truth, as I'm about to show you, the dunderGet method of a function is nearly identical to the dunderGet method we have here. This is the implementation of the dunderGet method of functions, or well, a pseudo-implementation of the actual get method that was written in C. As you can see, it's nearly identical to what I just implemented for the favorite descriptor. If the instance is none, which happens if we get a function using a class attribute directly, this dunderGet method will simply return self, which here means the function itself. If we access the function on an instance, that instance will be passed as the argument for the instance parameter, which means that we make it pass the if statement and then return something that is called a Py method. And this is the bound method we saw earlier. When it gets created, it gets the function as we pass self to it, and it gets the instance as we pass the instance parameter to it. And that is how a bound method already knows which instance it is bound to. It happens when the function is accessed. To show that in action, if I access the playNote method directly on the class, there is no instance, so instance will be none in the dunderGet method, and we will just get the function itself back. This is because accessing it in this way is more or less equivalent to calling the function's dunderGet method directly and passing none for the instance parameter and the guitar class for the owner parameter. Likewise, if I recreate my Warwick instance and access the method on that, we get a bound method back. This is because this is roughly equivalent to calling the function's dunderGet method directly, with Warwick as the value for instance and guitar as the value for owner. And this is the magic of self. When you access a function using an attribute, the descriptor protocol takes care of binding the instance to the function in something called a bound method. And functions are not the only descriptors that are built into Python. There are some other built-in descriptors that you've probably already used, potentially without knowing that they made use of the descriptor protocol. I'm going to show you 3 other built-in descriptors that you've probably already come across. First, the class method descriptor, which is often used as a decorator, wraps around a function to bind the class and not the instance to the function. It does this by implementing an alternative dunderGet method that binds the owner parameter instead of the instance parameter to the function. One difference with a regular function is that this binding happens both if you access it on an instance as well as when you access it directly on the owner class. Likewise, the static method descriptor also wraps around a function to provide an alternative dunderGet method. This dunderGet method will not bind anything at all, but will just return the function as is, even if you access it on an instance. And finally, the property descriptor, also often used as a decorator, allows you to easily create getters, setters, and deleters. It does that by calling the methods you specified in its dunderGet, set, and delete methods. And with those descriptors, we've come to the end of my talk. To summarize, the most important 2 takeaways are: 1. Descriptors allow you to customize attribute access, which means that you can abstract away logic behind the normal flow of interacting with attributes. And 2. This is precisely what functions do. They are descriptors that modify attribute access to create bound methods. There are also a number of important things that I haven't covered in this talk. First, I haven't really talked about dunderSet and the dunderDelete methods. These are important as the presence of these methods in a descriptor actually influences the lookup sequence Python uses. Descriptors with a dunderSet or a dunderDelete method are what the docs call data descriptors. A descriptor with just a dunder get method is called a non-data descriptor. Since this distinction can be tricky to get, I recommend you to look it up in a good resource, like Raymond Hattinger's tutorial on descriptors, or in a book such as Fluent Python, which calls them overriding and non-overriding descriptors. Finally, I also haven't mentioned the dunder set name method. While this method is technically not a part of the descriptor protocol, it is often used within descriptors to get access to the name of the attribute that was assigned to the descriptor. I'd like to end my talk with a quote from Lee Siegel. "I'm writing a book on magic," I explain, and I'm asked, "Real magic?" By real magic, people mean miracles, thaumaturgical acts, and supernatural powers. No, I answer, conjuring tricks, not real magic. Real magic, in other words, refers to the magic that is not real, while the magic that is real, that can actually be done, is not real magic. There is a lot of magic in Python, and some of it is of the deeply arcane kind that we, mere mortals, cannot really touch, as it's hidden away deep in Python's internals. At the same time, most of the magic in Python is of the kind that we can use, that we can hook into. In this talk, I've zoomed in on a particular piece of magic, self, but I would like to challenge you to go out there and dive deeper into Python's data model, to discover even more magic and to use that magic to create meaningful abstractions and objects that behave just like Python's built-in objects do, to provide the users of your code, including yourself, with a high-level interface that is familiar and that makes sense. So, go out there and practice magic. With Python, we can all be magicians. This is it. I hope you've enjoyed it. If you want to take another look at the slides of this talk, you can find them on my website, sebastianzeef.nl. You can also follow me on Twitter or connect with me on LinkedIn. You can also often find me on Python Discord as Sebastian. In any case, thank you for your attention, and I hope that you'll enjoy the remainder of Pyjamas.
And yes, no double mute. Eh? Here we are again. The night still is Joan. We have still a few presentations lined up. So our next speaker, developer Steve, who is joining us. Hi, Steve. I really love your cousin. Where are you joining from?
Thank you. I want to say the internet. Also, just a note here. It is. I'm in Australia. I'm out in the countryside, and it is currently 30 degrees Celsius. For those that are playing at home in Celsius, it's actually really hot and really hot to wear, but it's fun.
It's fun. It's been a lot of fun, and we're gonna have way more fun with your presentation. Which, if I can pronounce the name, I've been practicing the whole night. It says debugging Schrodinger's app. Is that the right pronunciation?
Perfect. 2 Python thumbs up.
So thank you very much, developer Steve. I just added your slides. Please feel free to start whenever you feel like, and see you in a moment.
Amazing. Thank you. And hello, everyone. You might be wondering why I am in a onesie. And well, this is my first time speaking at Pyjamas Con. It's so amazing to be here. And I was so excited because I've done like a lot of talks over the years, but well, this one I got to do in an orange onesie because it's Pyjamas Con, right? So I hope you're all safe and well, and also wearing your amazing onesies too. Actually, drop me a tweet on or a social media anywhere at Developer Steve on most platforms. Drop me a tweet with your selfie with your onesie so as well. Anyway, I digress. I'm going to switch to my slides and reset my timer. There we go. So hello, everyone. Really amazing to be here. As I said, my name is Developer Steve. I'll get into more about that in a moment. Some things I wanted to mention at the start of my talk. I hope you all get something from this, other than please don't wear a onesie in summer without a fan on because audio. I want to keep my audio nice and clear. It's kind of hot, but it'll be fine. It'll be fine. It'll keep me on my toes. But as we go along, please drop all comments, questions, and emojis into the chat as we're going. If you're watching this in the future as a pre-record, hello from the past. I hope you are well. Please do not be alarmed if you are watching this in the future. Dinosaurs are not walking amongst us once more. So just wanted to clarify that. Also, I am on the Discord, so please drop any messages you want there as well. I do have a disclaimer before we start. Oh, and it's got an asterisk. That makes it twice as bad, right? No. This disclaimer is fine. I have a lot of tech jokes / developer jokes. I've been a developer advocate for many, many years now, and well, I collected these in my adventures and my travels. This is the first time I've been wearing a dinosaur onesie while presenting, so it's always a first, right? But I do have a lot of tech jokes. This is open source, so please take it with you. And I love doing these at the start of my talk because, well, it makes everyone smile, and that's always important. So how do fallen trees check for errors? You might be thinking, how do fallen trees check for errors? Well, they use log files. Haha, there we go. Kind of related to today's talk, but we'll get into that as we go along. I have 2 demos and a whole bunch of, actually, there is a couple more tech jokes in as we go through. You'll spot them because you'll hear the silent boom-booms. No, I won't play that. But anyway, like I said, my name is Developer Steve. I've been a developer advocate or developer evangelist for a number of years now. I am with a company called Lamigo. I've got a little bit of a demo to do as we go through as well of what Lamigo is and how it works, and also OpenTelemetry, because OpenTelemetry is really exciting. But we'll look at that because there's some auto magical ways to do that. Funny story. So I have been a developer advocate for so many years now. I've done many, many conferences. Again, first time in onesie, just for the record. But from all connecting to so many amazing communities and doing so many different events all over the world since 2014. I had to think back then. Everyone started calling me Developer Steve. So when I got married in 2018, that's my wedding photo on the top right, I 3D printed the top of that cake the night before my wedding because I like to live dangerously sometimes. I actually had its own mobile number too, but whole other story. We combined our last names, and Kuchin is my married name. So when I legally changed to my married name, I thought, I'm going to make Developer Steve my middle name because everyone calls me it anyway. So turns out you can do that, and well, I did. You know what? I didn't mind though, because I mean, I've been coding for so many years now as well. So since the age of 8, I was basically, that was just a few years ago, right? Well, no, but there we go. Lost my slides. I've been coding since the days of QBasic, for those that remember it. Actually, if you do remember it, please drop it in the chat or hit me up on Discord, because I always love hearing people's developer origin stories. But I have been writing code since the days of QBasic back in the day. And going through my developer origin story, like that was humble beginnings, and always great to, well, get a feel for how code worked. And it was pretty basic, as the name suggests. But even going through digital agency, building out applications and, well, IoT things and all sorts of different crazy wild projects in no time at all, was literally organized chaos. Building applications that can not only scale well, but, well, I could support them as well in no time at all because, well, it's a pretty chaotic environment. Anyone that's ever worked through digital agencies and sort of building out tight timelines and, well, building out the entire world and supporting it with, all at the same time it's often quite troublesome and something you kind of build up a tolerance for, in the way that when you start to build applications, after a while you start to build them with the idea that I might be building for very small user group now, but it's going to scale rapidly, like really, really quickly as users adopt it and, well, as users hopefully adopt it, and the functionality starts to build out. Which kind of brings me to what this talk is about, which is building things that scale from the onset, like from that initial deploying project stage, or even that concept, building things out with the idea that at some point you're going to need to build out more robust ways to support this application at scale. And if you think like building a Python application out just for, building out an idea, but then also deploying it into the cloud native world, you need to really make sure that you're not only monitoring, observing, and sort of doing the right tests so that your end users have a great application experience, but also that application isn't costing like huge sums of money when you start to go to like insane scale. And by crazy scale, I mean, you might start out with 10 users now, but you might end up with 100,000 users down the track. That little tiny bug that you may have missed, or may not be sort of spotting in production now at that scale is going to cost you not only a lot of money, but also potential users as well. So one of the things I always love, I'm sort of multiple language adopter. Like I always try and keep across as much of the different languages as I can as possible. And for me, Python is really cool because it is so versatile. Of course, we already know that because, well, we're all sitting we're all sitting here in our pajamas watching this amazing live stream and building out some really, really cool apps. But previously, like it was actually one of the first languages beyond basic, of course, that more mature languages that I first started to learn. And I did that by building out a game, a multiplayer online game with a friend. And I used Python to be able to build out, taught myself Python 2.4 back in the day from memory. It's been a while. To build out using Tickle to build out a game client that would connect into some APIs that one of my friends had built with a game server. Which kind of brings me one of the other use cases. Like I've used it extensively to also build out APIs. Actually, the APIs for that game were built using Python as well. But over the years, I've also built out a number of different other APIs using Python, including some financial services APIs, which it's always great for because not only do I find Python as a senior developer, not only do I find Python one of those versatile languages, but also a heavy lifting one too. Which is another great use case here because, as we know, data science loves Python and Python loves it equally back because it is literally one of those heavy lifting languages that you can do any manner of different data science projects with. Of course, web-based frameworks in Python, amazingly great to build out a really quick website and then be able to, a web-based application, and then be able to expand it like really, really easy as well. And shout out to Django here because it's one of the ones I've used previously. And one of my other favorites, I love Flask. So the application I'll be playing with today, I've built in Flask because I like Flask. I really need to put an I love Flask meme in. Totally, I keep meaning to do it anyway. And of course, Internet of Things. Oh, I love Internet of Things. Actually, I have one on my desk at the moment. I won't pick it up because I'll start talking about it. I'll be here for another hour. But yeah, Internet of Things is one of my favorites. Like I said at the start, I actually 3D printed the top of my cake and it had its own mobile number. The guests at my wedding were able to message the cake and change the color of the top of the cake. I actually reused that. It was MicroPython too, just thought I'd mention that. I actually reused that about a year later when I bought this new coffee table and it looked just like an iPad. It was actually unintentional until it turned up and I was like, oh, this looks like an iPad. I can put lights in that. And then also control them as well, because I mean Python, right? And well, there was 300 LEDs in this coffee table, so of course I was going to control it with all the things. Through all these experiences, though, and to sort of add to the versatility behind Python, one of the things I've always been mindful of is beyond that deployment stage, beyond that stage where you've gone right, the requirements for this application, they're all complete, whatnot. Let's deploy to cloud. And this is where Schrodinger's rules of observability start to come into play because it's something I've always been mindful of as a dev building out apps. And keep in mind, we as devs, as technology people, as people wanting to make a difference using our code superpowers, like these applications we build for our end users to be able to do something meaningful in their lives. Part of the deployment scenario, if you will, is to also make sure we're monitoring these applications too. And this is where Schrodinger's rules of observability, that's a tongue twister, or a cat twister, if you will. Yes, let's go with that, come into play because this was essentially a thought experiment that kind of aptly describes the quantum world, but it also applies to other things like application development. Because unless you are observing the application, the deployed application, even in whatever stage it's in, unless you're observing that application, you won't know whether it's throwing an error or it is throwing an error or what it's actually doing. And so Schrodinger's rules are that it's a paradox of quantum superposition, but in an application standpoint is you won't know whether there's an error or no error if you aren't observing it at all. In fact, it's actually doing both at the same time until you're observing it that it isn't throwing any errors, if that makes sense. Of course, in dealing with building out local Python applications, this is really easy to do because there's a multiple of ways to do it. So you can use the core language platform debugging options like print, logging, PDB, etc. And these are all built in and ready to go inside the core framework now. Then, of course, you can use different libraries. Like, I mean, one of my favorites, pprint, because, well, it's really handy for dumping out dictionaries or arrays to be able to see what's in there and if it's in the right position that I was expecting it to do it in. And then, of course, you can use IDEs as well with any variety of plugins. And some of the plugins will actually use those aforementioned methods to be able to do some debugging like live while you're building the code out, which is always super, super handy. And that's for the likes of VS Code, Eclipse, and well, whatever other tools, or IDE tools that you're using as well. So this is where this is our first Python joke. This is where this application is one of the demos we built out to be able to not only demonstrate how these errors can occur, but also ways that you can debug and find them. So this is what I aptly call Schrodinger's Python app. Now, what do you call 8 bits in Python? This is a bit of an old joke. So if you do know it, please drop it into the chat. Please drop it in the chat. But you call it a snake bite. Oh, see? But I can feel the face palms. It's always really weird. Anyway, I didn't say they were good jokes, but I did have a whole bunch of them. Anyway, this application, I'll have the code at the end of my talk if you want to go play with it. It's containerized and also you can run locally as well. And like I said, it's a Flask app, but I'm going to talk a little bit more about that in a moment. It's essentially a to-do app. So, well, it is a to-do app. So yeah, you enter some to-do items, and I've got some little little things in there so you can test some HTTP statuses and whatnot. But I don't want to give away spoilers. Let's go look at that in a moment. So inside this application, just to talk through how it actually works, of course, as I said, it's Flask because, well, it's Python and Flask because I love the two together. I don't think you can do it without it. Anyway, it's a Python Flask app that uses Alchemy for some basic databasing. There's an SQLite database that it creates on its own as well that it uses to store its to-do items and then remember them and make sure they're there. It's a fairly basic database schema-wise, but it doesn't need to be complex, and we'll keep it simple. There's a couple of routes in there. So for starters, and there's a couple beyond the ones that I'll talk about here, but we'll get into that when we get to it. There's a to-do, which will just get to-do. So it obviously just gets all the to-dos out from the SQL Alchemy database. It posts, it'll handle some post queries, so you can create new items, update the status of, so you can mark them as complete, etc. And then you can delete them as well. Which brings us to our first demo. Just going to switch back quickly to make sure, no comments, everything looks like it's working and the wheels haven't fallen off yet. And there's no messages from anyone. This makes me sad. Please drop some emojis into the chat now. Just, yeah, get creative with the emojis. Anyway, dinosaur ones. Put dinosaur ones in there. All right. So let me switch over to my code. There we go. And now I can see that my Triceratops head's out of the way. That's better. So this is my code. Hopefully you can all see it fairly well. Yep, looks like you should be able to. If you can't, please drop in the chat and I'll make things bigger, but I tried to get everything to line up. So this is my code here. I've got, like I said, I've got some basic routes in here, like doing some get, some add, handling some post queries, and delete and update. There's a couple others, but we'll look at those in a second. Like I said, with the thing, like when you're working locally, obviously, is you can use them multiple different ways to be able to see, well, what the application's doing. So if I do that, actually hit an extra character there, and now I've just learned that it's actually sanitizing because it didn't break. This is good. This is good. Nothing like testing live. I don't recommend doing that at home. Anyway, as you can see, as I'm interacting with the app, of course, I've got Flask in debug mode. And I can see exactly what it's doing. And if there's any errors, I'm able to fix that. But I want to make sure that I can see those errors occurring. So I've got a couple of little fun things. Let me delete that one. Fun things sort of built in so that I can test like HTTP route status errors, for example. So if I click cat, you can see it's created this extra button called cat here, which is kind of funny because, well, it's Schrodinger's cat is the thought experiment. This is kind of the idea for the app. So if I click that now, you can see on the right-hand side in the debugger, I can actually see it's created a 400. And Flask, of course, is handling that as it would expect. So it's actually redirecting me back. It's throwing a bit of an error and then redirecting me back. Now, if I click cat again, it's going to start cycling through the 400s, so I can start to cater for particular HTTP statuses as they occur as well. And if I click that back, I actually think that may actually be unhappy with that. Even more unhappy with that one, because that was a 401. There we go. Now I'm getting a 402. And I can go keep going through that, and it's just going to keep throwing the statuses. And at the same time, I can see what this app will do and what the infrastructure that it's running on, in this case, just local, how it can actually handle those. I can also do, and I've got this one built in, a particular status type. So HTTP status 418, that is my favorite. You might be thinking, why would someone have a favorite HTTP status? I mean, other than 200, of course, which is everything works fine. 418 is I'm a teapot. It's still one of my favorites because it means nothing and it doesn't do anything, but it's kind of fun. Anyway, have a look that one up. 418. I'm a teapot. Got introduced one time as an April Fool's Day joke, and well, it's never left. Never left. I'm kind of glad though, because while it doesn't do anything, it's just fun. But if I create that one now, you can see it's going to send that through as well. And as expected, it doesn't really do anything other than just send a fun status through to my app, but it seems to handle it okay. That was kind of the first demo. So you can see there, like, debugging relatively easy. But if we go to deploy this application, that's where things get a little bit interesting. And again, if you think like building out a local demo to be able to, prove an idea, or at a hackathon, just build out, the team's project that they want to build in the time frame. But the next stage of any project, even just building out an idea for something you want to do, like a IoT cake or a coffee table, is just part of the process, because inevitably at some point someone's going to come over and see that particular thing, and everyone's going to all of a sudden want to use it or buy it or do it themselves, or maybe you need to do a write-up for it. So building for scalability is always super important from the early stage onset. Now, I'm going to mention here too, when you start to think about deploying to cloud and scalability, you got to think like, scaling the database and scaling the web server and all the infrastructure that sort of runs that particular application, which is entirely doable and fairly easy, but you need to make sure that you've got the right processes in place from the start. Now, special mention for this phrase, because I've been here, and it's always my first thought whenever anyone always sort of goes to, well, there's a problem for that particular app, and I'm like, it was working fine when I was running it in my Docker. Like it was fine when it was working in my environment. And when you think like a deployed application across cloud native infrastructure, you've got a lot of moving parts and a lot of components, and any one of those can cause an error, which will have downstream effects on completely potentially unrelated parts of your application. And that's the thing with cloud native environments, is they're literally many components that will sit behind various elements of your deployed applications to enable them to not only scale super quick, but also be able to reuse functionality like really easily. And quite often, like, these can start off relatively simple, particularly as you're building out that idea or that project in its early stages, and become rather complex sort of down the track as you add more services in, or maybe there's a new feature on a cloud being announced at a particular conference. Shout out to AWS conference this week and reInvent in Vegas. There's going to be so many announcements. Even with that, you can imagine, or as we see in the industry quite regularly, is that one service which has been running for many years all of a sudden gets a whole bunch of new features very quickly, which may depreciate some of the features that you're already using inside your app and may not realize, because there is so many announcements often in the cloud native space. And all of a sudden you get that one error appear in that one service across, maybe even just in that one region across the multiple regions you're running in. But ultimately it's going to mean, well, the Murphy's Law raises its head at the most unopportune times, right? And you're probably going to get a call at either 2 a.m. someday, or on a Friday evening when you're trying to play that particular game and you're halfway in you've just been deployed to the island, and yeah, you get that alert to say, hey, there's something wrong, it needs to be fixed, like fix it now, why is it broken, fix it. Murphy's Law often knocks when you don't want it to do that, and well, you want to make sure you've got the right tools in place to be able to spot it. And this is where distributed tracing can help, because it can take that multitude of services sitting behind your application and put it into some nice order and create a nice little, I like to think of this as an adventure map. So, and if you think about it, like having that end-to-end trace behind a transaction kind of helps, because you can see that your application triggers this service, which passes a message into this service, which then gets a response from this SDK, which then in turn does all this other stuff. And being able to see that nice lineup means that you can identify where the error is appearing inside the flow, and maybe investigate and sort of understand that it's not actually an error occurring in that particular spot in the flow, but something that happened 2 lines away, 3 services up in a mountainous region of this fantasy land that your application is adventuring in. You know what I mean. I just wanted to tie it back to something fun. But this is where distributed tracing is able to tie in and spot where that particular error is occurring as part of your application's flow. The best part is, and like I've been here so many times over the years, this is all agentless. Wait, I have a fun meme I'm going to throw up here. There we go. Agentless. This is all done I can't say it, but you know what I'm trying to say. This is all done without the use of agents. So you don't need to keep anything running on your particular server infrastructure, your cloud native environment, or even just having a service running alongside your production environments to be able to spot everything. This is all done through an amazing new implementation inside of the tech industry, which is becoming really widely adopted, called OpenTelemetry. And I've seen a few folks at the conference talk about this and OpenTelemetry, and I think it's great, a great way to standardize not only the logging and the metrics and traces that applications, platforms, and infrastructure are generating now, because like I've been through that entire world of like digging through log. I think we all have at some point, digging through logs to find that particular one thing, that needle in the haystack that you may or may not find, but you need to identify because there's an error or there's a ticket being raised for an error. OpenTelemetry helps solve this because it's an industry standard, vendor neutral way to be able to handle logging, metrics, and traces from applications and from infrastructure and cloud native as well. So, and it's been around since, OpenTelemetry's been around since 2019, and it's part of the Cloud Native Foundation as well, which is great. That industry standard approach just means that, one, you don't get vendor locked into anyone to be able to use anyone's particular, well, you shouldn't be, anyone's particular company way to use OpenTelemetry to trace your application. Friends don't let friends do that. Using pure open telemetry approach means that you can not only avoid that, but you can make sense of your application too. The best part is, and shout out to the open telemetry community here, best part is because of that industry standard and community approach to being able to handle traces of metric data, there's a multiple of branches within the overall overarching community that are building out more commonplace implementations of different languages and different stacks and ways to integrate very seamlessly and very easily. So as you can see there, there's a Python one, and I'm going to say other languages because this is a Python conference and we love Python. But there's a whole bunch of other languages there too. Now, shout out to the community and communities sort of here as part of the OpenTelemetry group. If you are looking to use any one of the components, please contribute back where you can. It's always important as adopters of open source, as products of open source, that we contribute back when we can. So please, if you already are, thank you. See, you've got somebody in a dinosaur onesie saying thank you for contributing. How awesome is that? But yeah, thank you for any contributes that you do. If you are looking to get involved, this is a really great community. They've got a Slack group and everything you'll need to know to get started on their website as well, and to also get up and running with it. So yeah, please contribute back to where you can. At Lamigo, we do contribute back to the core project, and we also maintain a number of our own open source traces based on pure open telemetry approach. Again, friends don't let friends get vendor locked in, and we're very proud to support that as well. our open telemetry traces that we're going to be looking at one of them in a moment. You basically install them. So just pip install the tracer. Reference in the code is literally just importing the library. Like that's it. It's kind of cool. Auto magical. Woo. And set 2 environmental variables, which I'm not going to show you with the platform because one of them is also my token. So yeah, anyway, can help you through it if anyone needs to set it up, and we've got it all written up in our documentation. But the 2 environmental variables the distribution library needs is the token for your free tier account, which is what I'm using here, and also the service name that you want to appear in the traces. Yeah, that's kind of it. It's really easy to set up. So like before, this next demo uses the same demo, but I've containerized it. Ooh, Docker. How awesome is Docker? I've got that running on an ECS, and I've also hooked up SQS using some environmental variables, but I'll show you that one in a second too. Again, this is to just demonstrate how OpenTelemetry can help you trace your app and then be able to, well, do some traces yourself. And then, of course, I'm using OpenTelemetry to pick up some metrics auto-magically. Demo 2. Oh, I'm on time. Well, I'm pretty close to time. Only got a few more slides after this one. So the code bits we're going to be looking at this time in particular are using the variables, the environmental variables, which I've got set in my app. Can't show you that one either because I did that one time and people started sending messages through my my queue. So yeah, I won't do that one. But you know how they work. Also, I've got instructions for this on the repo as well. So if you check that out if you want as well. The other one is, so I do have the the Lamigo OpenTelemetry distribution in here to be able to do some traces that we'll look at quickly. Literally, that is the only code that I've got in there particular to that. Like, that's it. It just loads the library and sends through all its magic, all its OpenTelemetry to be able to see some great tracing. Anyway, that was it for that one. This is the ECS that I've got running. As you can see, well, I'm not going to click through to the task because that is where the environmental variables are actually visible. And I like you all, but I'm not going to give away my tokens. Sorry. But yeah, again, check out the repo. You'll be able to see it all there. There was an error there, and then it quickly fixed itself. Isn't that great? See, that's when Murphy's Law goes to come and then goes away. That's what we like. Well, actually, that it doesn't come at all. But anyway, if it's going to do it, at least do it that way. I've already got my AWS account hooked up to Lamigo. That's quick and easy to do. And then through that, it's able to trace some basic. It'll not only spot your containers running, like you can see there, but it will also see any serverless functions you've got running and trace those as well without even doing anything, which is kind of cool. What that library, though, does is also add some traces at the transaction level inside the container. So it's like further information is able to come out on each transaction. Let me show you what I mean. So if I do some tests like I did before, which are all going to run fairly similarly to before. So I'm going to throw some, actually, I'm not going to do the cat one. I'm going to throw my favorite, 418. There we go. It broke. Oh, no. So I'm going to finish that one. Actually, let's do cat as well. There we go. So that'll send through, that'll send through some different ones. Now, 2 of the other, I'll just clean those up so that everything stays on screen really good. There we go. I do need to add a reverse sort. So the newest one appears at the top. We'll add that to the to-do on the to-do. Anyway, that just went down a whole other Schrodinger's thought experiment rabbit hole. But this other one I've got set up is called Meow. So what this will do is put multiple Meow messages into queue, which will be able to end-to-end trace from the container directly into SQS as part of like a holistic transaction view. So if I keep clicking that now, it should, there we go. It's going to do multiple meows. And as I keep clicking that through, that will then appear as a end-to-end trace inside as part of our OpenTelemetry tracer. That's probably enough meowing. So now if I click the See Traces button, or I can just click into Transactions tab, but let's go to Transactions tab. Hey, there we go there. So I should start to see there's an error there that you can see, and I can click through that and then see sort of more detail about the particular error that occurred, and also some really nice, easy to see log entries associated just to that transaction, which is one of the things I love the most. Is I don't have to dig through like all those logs because done that before, and that hurts. That hurts worse than more than wearing a onesie in summer in front of a whole bunch of lights. Whole other story. This one time I did it for a couple. Oh, you're here. Anyway, with the end-to-end traces though, these are the meows that I was sending through. You'll be able to see like from the application itself. You can see there the route that's come through is called meow one. Actually, let me just make sure that's big enough. There we go. That's called meow one. And then I can actually trace that through to, well, the route's called meow1, but it would have triggered meow2 because it was incrementing adding one, which is the body, the message that it sent through to the SQS. And you can see that there as well. So as I go through and use the application, or users are using the application, you can flag particular errors or particular instances that are occurring really easily, but then also see further information just for that particular transaction and invocation as they're occurring, which is really, really cool. Because it ultimately means it's less time that I'm going to be digging around looking for, well, anything that I need to find out to be able to do any sort of intelligence gathering for a particular error or trace that I'm looking for. So you can see like things super, super quickly and super, super easy. See, there's that 418. See, I'm a teapot. It's my favorite one. Anyway, yay, second demo worked. Let me switch back and almost done. And then I'll switch back to the app and see if there's any questions. So just some takeaways and some things to think about, other than the fact that, yay, both demos worked and you want to get hands-on with the code will be available. I'll show you in the next slide. But always remember to build for scale. Like no matter what you're doing, those humble beginnings, building out just from the moment you do get in it, you're basically buying tech debt. So make sure you future-proof yourself as much as possible. Not even yourself. Might be someone else who'll be picking up that particular app down the track. Always make sure you document your thoughts and even where the application was intended to go, just so those that particular section of the app that someone may pick up in that future time, like make sure you help them out as much as you're going to help yourself in the long run. So always document as well. I should add that as a point. But, rinse, repeat, and refine, like work out what works, work out what works well, and then also be always looking to refine how that particular part of an application is working. There's always ways to make an app better, in particular so that it uses less resources, saves the user's time, and ultimately saves you money or saves your resources. And monitor and trace everything. That's super important across the board. So no matter what you're building out, make sure you're looking to deploy with that in mind, because you're going to future-proof yourself. Not only future-proof yourself well, but you'll future-proof everyone using that app down the track. And your end users will thank you for it. I'd like to think they would thank you for it, but if there's no problems, they're probably not going to know. That's a whole other thought experiment there. But you know what I mean. Please grab the code for yourself. I'm always looking for contributions, always looking for people to help make it better. And also stars. If you want to add a star to it, I won't say no. In fact, thank you in advance. And just finally, please always remember, use your tech superpowers for good. You probably all do anyway, so thank you. And remember to be excellent to each other. Thank you very much.
Thank you, developer Steve. Great presentation. People were at the shop. People were saying, "Loving your energy." So I love your energy as well. Especially that after you, it's summer. How can you have energy in the summer? We all have. So I have a question here for you. Yeah, go ahead. Yeah, I'm sorry.
Oh, no, I was going to say, it is actually quite hot in here, but my energy is keeping me cool, I guess. So let's go with that.
Perfect. So the question reads, are you able to use it with GitHub Actions?
Yes, you can. I haven't set that up yet, but always looking for contributors. But yes, you can.
Yes. So that's the only question I have. But anything that you want to say before closing insights?
Actually, I want to ask you, I have two things. I want to ask you a question. One of my favorite ways to ask anyone in tech is, what was your first computer?
Oh, my first computer. This is a very long story, but I will make it short. So I had the opportunity back in 2000 to build my own computer. I was in college, and I remember that at college we didn't have the computer didn't have hard drive, so you needed to use a floppy disk and boot the old operating system, then take out the operating system OS and use the software to to do COBOL, Pascal. So I built my computer. It was a Pentium 2, Pentium 2.
Amazing. And I just want to say thank you to all the organizers for putting this on. It's a lot of work, and yeah, thank you. And everyone in the community, please drop a message in the chat. Thank the organizers.
Yeah, thank you. Yeah, as all the organizers. And I think with this, we're closing this section 5, and then we're gonna take a break. But I want you to stay here. I mean, take a break, go eat something, go have some rest, go stretch your legs. It's been a long day, but we still have our presentations. That's a good thing. So I want you to take a break, and everyone, and come back later. And it's been a lot of fun, Developer Steve, and I hope to keep talking to you during the in the metaverse. All right?
Amazing. Thank you.
Yeah. Bye.